Hey, this is Juan Tutors, and today we are working on the August 2024 Geometry Regents. This one is let's say one of the tougher of the three regions between Algebra 1 Geometry and Algebra 2, but I'm really excited about getting through this one with you. Our goal is to pass the Regents, if that's your goal. Our goal is to get an 80 or above on the Regents, if that's your goal. If your goal is to ace this Regents, this is definitely the video to go to, because I'm not just going to go through every single question and show you how to do it. I'm actually also going to show you how to use process of elimination using correct, rigorous math that you can handle to be able to eliminate choices and get questions right, even if you didn't necessarily know how to do them. I'm not every single question is going to get every single choice eliminated, because that's not the goal. One of my goals is to just get you the highest grade possible. So I want to show you how to do that. One of the first things that I tell students, though, to cross out, this is the very first piece of advice and the very best piece of advice, that if you just assume that what I'm about to say is true, then you can get a passing grade just from this piece of advice. So I'm giving you this gift right now. Right on the beginning of the test, it show that note that diagrams are not necessarily drawn to scale. I have my students actively cross this out and write the words almost definitely. Okay? Now, a lot of teachers might disagree with me on that, and that's fine, but I'm right and you're wrong, because here's the thing. This test, they are trying, you might disagree as a student or as a teacher, but as a student you may disagree but they are trying to make a test that you can actually pass. They are trying to make a test that actually is testing what in their minds is maybe what they feel is the important stuff. They can't create a test that's just gonna mess your brain up and break your intuition the entire time and then call it a good test. So what does that mean? Every diagram except max 1 or 2 is definitely drawn to scale. Max 1 or 2. And this test is full of diagrams. If you find two diagrams that are truly very, in a bad way, not drawn to scale, I will give you all the money in your teacher's pocket. But that's not going to happen. You're going to see in other tests, and I just want to be clear, in other tests, I used a looser definition of not drawn to scale, and in this of drawn to scale, and in this test, I'm going to use the same definition, but I'm going to be a little bit clearer about it. I'm going to be more intentional about it, because I want to make sure that you know what it means to be drawn to scale, and so that you could see how you can use scale to answer the question. Okay, so first, from that point, we're going to hop right over to number one, the multiple choice questions. We have to answer every question in this part. Everyone will receive 2 credits. Right, 2 credits. Wrong, 0 credits. No partial credit is allowed. Utilize the information provided. I want to use the word all. Okay, if you if you find a problem, if you find 2 problems that has a piece of mathematical information that's not actually useful or relevant at all, again, I will give you all the money in your teacher's pocket. The thing is, we did you a disservice when you were in elementary school, and we taught you that you should cross out irrelevant information. That's bad advice, terrible advice, horrible advice, causes failing grades, because they're not doing that on Regents. They're not giving you irrelevant information. So in fact, we teach that in elementary school, and then in middle school immediately hop to having every single question having only relevant information. So bad advice. Diagrams are not necessarily drawn to scale, not necessarily cross that out and put almost definitely. And in fact, if you can confirm that that the diagram is drawn to scale, then you could just use scale freely with 100% certainty. For each statement in the question, choose the word or expression that of those given best completes the statement or answers the question. Record your answers in a separate answer sheet. Fine. Number 1. In right triangle LMN below, LN is 8, MN equals 15, and LM equals 17. And there's your nice diagram. And I'm going to check, look at the diagram. I see an 8, I see a 15, a 17. The 17 looks a little more than double the 8. The 15 looks slightly less than double the 8. And the 17 is definitely slightly longer than the 15. This diagram is drawn to scale. DTS, 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 DTS. So DTS equals drawn to scale. Drawn to scale. Drawn to scale. So this diagram is definitely drawn to scale. And then it says if triangle LMN is translated such that it maps onto triangle XYZ, which statement is always true? XY is 15, YZ is 17, or the measure of angle Z is 90, or the measure of angle X is 90. My brain is already jogging to maybe either 3 or 4 because of me being a test maker along with a test grader, but because I see 2 different letters with the same number, as opposed to choice 1 and choice 2, which is 2 different letters, sets of letters, and 2 different numbers. But if you didn't jive with what I just said, that's really very esoteric. That's the way my brain works. That's not even good math advice. I'm going to give good math advice right now. So here's the thing that you need to know. This problem will be on every single Regents in some form or another. How does this problem look? They'll say that this triangle, and they'll give it a name like LMN, and then this other triangle, which they'll give it a name XYZ, something like that, and they'll say that they're congruent one way or another. And then they'll ask you about information in a triangle that they didn't even display. And you're like, how am I supposed to do that? Well, the thing that you need to know in this case is that the letters, the ordering of the letters matters. LMN, 1, 2, 3, and XYZ, 1, 2, 3. It means that they have to correspond to each other in that order. So L corresponds to X, M being the second letter corresponds to Y, and Z, N being the third letter corresponds to Z being also the third letter. And now we have our diagram. How did I know that these two triangles are congruent? Because it says that the triangle LMN is translated such that it maps onto triangle XYZ. That's a rigid motion mapping one triangle onto another. That means that the two triangles are congruent. Okay? So, and with those vertices matching in that order, L correspond to X, M correspond to Y, and N correspond to Z. So that means that in this case, I could actually just read the answer off my new diagram. Let's see. Angle XY is 15, so XY is actually 17. So I'm going to cross that out. YZ is 17, actually YZ is 15. The measure of angle Z is 90. That looks good because it's right there and it's a right angle. That just looks correct. And the measure of angle X is 90. Actually, no, this is an acute angle. So that's not it. So in this case, the way to do the problem was to literally label it, and the way to do process of elimination was exactly the same way as getting the answer. So the one piece of information you had to know is that the letters had to correspond to each other in that order. Okay, número dos, number 2. Directed line segment KC has endpoints K, -4, -2, and C, 1, 8. Point E divides segment KC such that KE to EC is equal to 3 to 2. What are the coordinates of point E? Is it -1, 4, or -2, 2, or -3, 0, or 0, 6? So how can I use some process of elimination using rigorous math to eliminate some choices? If KE to EC is 3 to 2, that means that KE is longer than EC, and that means that E is farther from K and closer to C. So if I see that K has coordinates -4, 2, -2, so again, I said that E is closer to C and farther from K. If I see that the coordinates of K are -4, -2, and C are the coordinates of C are -1, 8, positive 1, 8 rather. Well, how can I get closer to C? I'm going to look at the Y coordinates in this case because they're nice even numbers. Halfway between -2 and 8 is the number 3. 3 is 5 away from 8, and 3 is also 5 away from -2. I have to be closer vertically to C, which means that the Y coordinate has to be bigger than 3, closer to 8 from 3. So it has to be higher than 3. The Y coordinate has to be higher than 3. The Y coordinate has to be greater than 3. And if I see choice 3, I've eliminated that way, and choice 2, I've eliminated that way. Now I'm down to a 50-50 chance of getting this one right. This is what I call a passing problem. And I'm going to talk about what a passing problem is in a little bit. But the moment you could eliminate two choices, you've got a passing problem. And in fact, 0.6 is so close to C that I'm like that proportion doesn't seem to be 3 to 2, K to C to 0.6 and 0.6 to 1.8. That seems to be like a larger proportion, and in fact it is. But fake student me might say, I'm not sure. I think this one's a little bit too close to C. I think I'm gravitating towards 1. And if you still have no clue at all how to attack this problem using correct math, then you can move on, guess number 1 and move on. And you get those points, which is great. So how do I do this question? So I've done this question in so many different ways. I do like to draw a quick diagram, because if you don't know how to draw this quick diagram, and forget about it. Where are you going to go when it comes to the graphing problems? -4 and -2. Here is K. And then 1, so this is -2. Here's 1, and then go up 8. That's all the way to the top of the arrow. Right here, that's 8. Here's C. So if I draw a straight line, from K to C, okay, I could actually I could graph here -1, 4, which is right here. And I could graph 0.6, which I want to see. Can I modify this a little bit? I didn't draw it well enough for me. I see why, because I put point C a little bit too close. There we go. So this choice 4 is right here. There we go. So you see that choice 4 is a little bit too close to C to have a proportion of 3 to 2, which is making choice 1 look a lot better now. So how do I actually do this problem? I actually make a table. I go K to E to C, and I make the X coordinate and I make the Y coordinate. The X coordinate of K is -4. The X coordinate of C is 8. No, is 1. And the X coordinate of E is this mystery number. So how do I get from -4 to 1? From -4 to 1, notice I add 5. And I want to point out, notice that 3 to 2, the proportion 3 to 2, 3 plus 2 is 5. So if I add 3 to -4, I should get the X coordinate of E. And if I add 2, that's going to check my answer very nicely, and because I should get 1 out of it. Okay, so I'm going to get my calculator out. I'm going to make it small because I need you to be able to see what I'm doing. But I also am going to make a nice big LCD so you can see what I'm typing. -4 plus 3. No, this test does not expect you to do arithmetic on paper. You don't have to know what -4 plus 3 is. I would love it if you did, but you don't have to know what -4 plus 3 is. -4 plus 3 is -1. Okay, and just to check my answer, because I need to know that I did it correctly, I'm going to do that -1 plus 2. I should get +1, and so that checks my answer. And so the X coordinate of E is -1. And I'm going to do the same thing for the Y coordinate. Why am I going to do the same thing for the Y coordinate? Because this can easily be a part 2, 3, or 4 question, or part of a part 3 or 4 question, or just the entirety of a part 2 question. The Y coordinate of K is -2. The Y coordinate of E is a mystery number, and the Y coordinate of C is 8. Notice, to get from K to C in the Y direction, I have to add 10. Now, 3 plus 2 is 5. If you double that, 6 plus 4 is 10. So if I just add 6 plus 6, I should get to the mystery Y coordinate of E, and add 4. I should confirm that by getting to 8. So that'll be a nice check. So -2 plus 6 should be 4. Good. And then just to confirm, I'm going to add the other +4 to that, and I get 8, which is the Y coordinate of C. So the coordinates of E are -1, 4, which is exactly what we had suspected. And on that note, I'm going to go to Número tres, number three, look at that subscribe button. In the right triangle DAN, the measure of angle A is 90 degrees. Which statement must always be true? Is it cosine D equals cosine N, or cosine D equals sine N, or sine A equals cosine N, or cosine A equals tan N? Now, I'm going to tell you how I would do process of elimination if I had zero clue how to do this problem. But the truth is, you should be drawing a diagram for this problem. Because honestly, I'm not sure how you would get past this problem and get 100% credit if you didn't draw a diagram. And not only that, if you do draw a diagram and you happen to know what cosine and tangent and sine are, you can actually just get this question just from the diagram. So now the ones that I'm suspecting are false. First off, it says must always be true. Always be true. And the only condition on the triangle is that it's a right triangle with angle A being 90 degrees. And to be always true, is it always going to be true that cosine D equals cosine N? The cosine of two different angles on the same triangle are going to be always a guarantee to be identical? This one's got to be false. There's another one that I suspect that's false. As a student, as a teacher, I know that it's false. Choice 4. I know that cosine and sine are cofunctions. So it is true that cosine and sine of two different angles have to be equal, which is making choice 2 and choice 3 looks good. But it actually, there's no reason for it to always be true that cosine of one angle is equal to the tangent of another angle. And in fact, the tangent function ranges from negative infinity to infinity. And in a right triangle, it actually ranges from 0 to infinity. Whereas cosine ranges from -1 to 1, and in a triangle ranges from 0 to 1. So 0 to 1 versus 0 to infinity, they don't even have the same range. So fake student me might suspect that this is true, this is false, but I just proved to you that this is false. So I, as a teacher, am going to cross out choice 4. Now, I can analyze choice 2 and choice 3 without drawing a diagram at this level, but I'm not going to do that. I'm going to show you how I do this problem by hand. So I draw a diagram. So we have a right triangle. Okay, thank you for nicely drawing that for me, software. So this is triangle DAN with the measure of angle A being 90 degrees. So this is angle A. And it doesn't say which one D and N are. Okay. Now the next thing is that what is sine, cosine, and tangent. So every year that I tutor, JuanTutors.com, every year that I tutor, I always learn something from one of my tutoring students. And right now I have 4 tutoring clients, but at one point I had 6, including my cousin. I was tutoring my cousin for a couple times, and she told me that she writes SOHCAHTOA like this: SOHCA over H and TO over A. SOHCAHTOA. And now, when students see it this way, I haven't had a student confuse which one's which at all at this point. So this is now how I teach it. If you're a teacher watching this, feel free to steal that. And if you're a student, definitely steal that. So what does this mean? Well, the sine of an angle is equal to the leg opposite that angle over the hypotenuse. The cosine of an angle is equal to the leg adjacent to the angle over the hypotenuse, and the tangent of an angle is equal to the leg opposite the angle over the leg adjacent the angle. And we're going to do 2 of these in a second, so that's why I said it without writing it down. So choice 2 and choice 3 remain, cosine D equals sine N. I'm going to choose for this test, I always choose a random problem to always try first for the purposes of instructional necessity. So, and I'm going to choose, in this case, it's always going to be choice 1, but choice 1 is crossed out. So then I'm going to go sequentially from there to choice 2. So for every single problem today, if I have to test, I'm going to test problem choice 1 if it's available. I've already crossed it out, so I'm going to go immediately to choice 2. It says that cosine D is equal to sine N. And so cosine D, here's angle D, here's the hypotenuse, the longest side of a right triangle. And then what is the opposite leg and what is the adjacent leg? It's always relative to the angle. So this down here is on the opposite side of angle D. So this is the leg opposite to angle D. Okay, and what about the adjacent? And notice that the word adjacent means next to. We know that for the SATs, you should know that adjacent means next to. So there's two sides next to D, but one is the hypotenuse and one is a leg. So when we say adjacent, we actually mean the adjacent leg. So this is the leg adjacent to angle D. And so choice 2, we're testing choice 2 because that's what the random number generator told us to test every single time. Cosine of D, well, it told us to check 1, but 1 is not available, so we go sequentially from there. Cosine of D is equal to the leg opposite to angle D divided by, what did I just say? That is nonsense, isn't it? Why is that nonsense? This is me being ahead. So sometimes when you're a little bit dyslexic, which I am, thinking about writing something in the future causes you to replace the thing that you're currently writing with the thing that you're gonna write in the future. And so that's what happened there. Here, SOHCAHTOA, CA over H. Cosine is the adjacent leg over the hypotenuse. So this is the leg adjacent to angle D over the hypotenuse, right here. And this is equal to the leg adjacent to angle D. Leg adjacent is DA over the hypotenuse, which is DN. Okay, next, how about, is that equal to sine of n? Well, sine of n is equal to SOH, S-O-H, leg opposite over hypotenuse. So this is equal to the leg opposite to angle n over the hypotenuse. Now, I know that you might just write opposite over hypotenuse, but if you don't know which one the opposite is, you should actually write, opposite angle n over hypotenuse. Maybe I'll write it next time I do a test like this. Okay, so leg opposite over hypotenuse and the leg opposite to angle n. Actually, now we have to identify those. The leg opposite to angle n is actually this side. It's on the opposite side of angle n, that's DA. So this is the leg opposite to angle n. And the adjacent leg is this, the bottom leg is next to angle n. The hypotenuse is next to angle n, but also the leg adjacent to angle n is down here. This is the leg adjacent, the leg next to angle n. Okay, so now sine is leg opposite over hypotenuse. Leg opposite is dA, and the hypotenuse is still dn. Okay, dA over dn. And look at this, cosine d and sine of n. So we have cosine of d is equal to dA over dn, which is equal to sine of n. So cos d does equal to sine of n. And in fact, it is choice 2. So a random number generator allowed us to check the exact answer that will happen to be correct. Okay, let me take a sip of this Fairlife milk. Fairlife, if you want to contact me to sponsor these videos, please feel free, because I'll probably be drinking these for many of the videos, unless somebody else sponsors me, and you know how that goes. But I will be talking about these milks in a little bit. Okay, but on that note, numero 4, number 4. In the diagram below, a parallelogram RSTV, diagonals SV and RT intersect at E. Which statement is always true? Is it SR is congruent to RV, or RT is congruent to SV, or SE is congruent to RE, or RE is congruent to TE? This is the point where I have to talk about drawn to scale in the strictest sense versus drawn to scale in the sense that I'm going to use on this test. This diagram, I used to call this diagram drawn to scale, but I was being a little bit too loose because of the fact that this diagram is not rigid. There's not enough information in the problem to make it rigid. So things can technically move around. However, this diagram satisfies all the conditions of the problem and doesn't actually create any pathological issues if you just assume that this is the diagram we're working with. So what do I mean? It says in the diagram below of parallelogram RSTV. RSTV certainly looks like a parallelogram. There are many other shapes that are technically also parallelograms that don't look exactly like one, but this is definitely a parallelogram. So I'm going to call this drawn to scale for this because it's a proper parallelogram. It's not like a weird, it's not like a square, it's not just a rhombus, it's not just a square, it's not like just a rectangle. It's also like it's generic, as generic a parallelogram as you can possibly have. Diagonals SV is drawn. That's drawn to scale. I mean, all line segments are always going to be straight. That's actually a rule for when we are just constructing problems. Like if the segment is straight, they have to draw it straight. And RT is drawn. And do they intersect at E? Sure they do. That's drawn to scale. So this is a proper parallelogram. So even though this problem is saying that it has to be true about every parallelogram, specifically, if it's true about every parallelogram, it has to be true about this parallelogram, which means that if we could find things that are false in this parallelogram, we can eliminate the choices. So look at this, SR congruent to RV. Well, SR does not look at, SR looks like half the size of RV. Not quite half the size, but they're not the same size. Cross that out. If it's not true for this parallelogram, it's not true for always every parallelogram, right? It has to be true about every parallelogram. This diagram is a parallelogram drawn to scale ish. You know, it's drawn to scale in the sense that it is a parallelogram. It's a proper parallelogram. Next one, RT congruent to SV. Now, I feel like if I were a student, maybe I would struggle to tell that RT looks longer than SV. So I might put an X there because maybe visually I struggle. However, there's going to be something that allows me to cross it out in a second. Check this out. SE is congruent to RE. Actually, visually speaking, I can tell that RE is longer than SE. Like it's like SE, and I have to extend my fingers to get to RE, right? So this one is not true for this parallelogram, therefore it can't be true for every single parallelogram. So how does that actually help me cross out choice 2? It actually helps me cross out choice 2 because I noticed that SE is half of SV, or it looks like half of SV, and RE looks like half of RT. And that there is a theorem that says that that actually is true. However, it looks to be true. So if choice 3 is wrong, choice 2 has to be wrong, making this one look very nice. And this one says that RE is congruent to TE. Okay, how do we actually do this problem? There's information that you need to know about a parallelogram. The first basic info is that the top and the bottom are both parallel and congruent. And the second piece of info is that the second pair of sides are both parallel and congruent. This does not eliminate any choices, but it does, it doesn't say that any of these is always true, but notice that the left side and the bottom side are labeled with 1 dash and 2 dashes and 1 dashes respectively, and which actually does cross out choice 1 because they're not guaranteed to be the same number of dashes. RT and then but choice 2 and choice 3 are about diagonals. There's a second bit of information though, that the diagonals bisect each other in a parallelogram. Okay, and in fact that's equivalent to stating that the object is a parallelogram. So the diagonals of a quadrilateral bisect each other, then the shape is a parallelogram. So, and vice versa, if the diagram is a parallelogram, then the diagonals do bisect each other. So in this case, it says that RE, choice 3 says that SE is congruent to RE. One has 3 dashes, one has 4 dashes. That's a Roman numeral 4. That's my clever dashing. So choice 3 is wrong. But choice 4, RE and TE, is congruent to TE. Both of those have 3 dashes because they're halves of the same diagonal. So it is choice 4. We used scale to eliminate every single wrong answer. So that's why using scale is a phenomenal tool. I'm about to use scale again to eliminate a bunch of answers, okay? Here, in triangle SNA below, UE is parallel to NA. UE is parallel to NA. That's drawn to scale. They look parallel. I was about to say DNA. That's when I'm reading one thing but writing something else. DTS. Okay. I switched to blue apparently. Drawn to scale. So that first off, then SU is 3. Nothing to contradict that yet. So automatically drawn to scale. SN is 11. SN is 11. Okay, that looks more than 3 times longer than SU, so that's drawn to scale. The next one, EA, is 13. 13. Now, this is where students might struggle. Does EA look like it's longer than SN? Well, it only has to be a little bit longer, and in fact, it is. If you take out a ruler, it is. So this is actually drawn to scale. The next piece, then, what is the length of SE? I'm gonna put an X because students love putting an X on the thing that they're looking for to the nearest tenth. I'm gonna use scale. I'm gonna use scale to eliminate a bunch of answers. Suppose I didn't know how to do this question, which I've been teaching it forever, so I do. I've been tutoring since 1999, as crazy as that is. So how do I use scale? If this thing is drawn to scale, I just confirmed that it's drawn to scale. There's a difference between confirming it's drawn to scale and just assuming that it's drawn to scale. I confirmed that it's drawn to scale, so I could use scale to eliminate choices with 100% certainty. As opposed to if I were to just assume that it's drawn to scale, then I can eliminate answers while crossing my fingers, hoping that it's one of the diagrams that is drawn to scale, which again, almost certainly. Notice that even the one diagram that technically had looseness, we were able to use scale to answer the question 100% correctly. That's kind of how these questions go. There is going to be one diagram that's not drawn to scale later, and the wiggle room really matters. And then there's going to be another diagram that's technically not drawn to scale, but you'll see why. And still, the scale didn't actually matter. You could just use it. So here, how do I use scale to answer the question? Since I've confirmed that it's drawn to scale, SE is guaranteed to be longer than SU, which eliminates choice 1. Too short. But SE is also significantly shorter than EA. So 17.9 is just entirely too long. Now, how about 3.5 versus 4.9? If I were to say something like this, SE looks like 1.5 times longer than SU. That would make it like 4.5. Well, the number that's closer to 4.5 is choice 3. I would maybe guess that and move on if I didn't know how to do the problem at all. However, this is the point. That's process of elimination. That would have given you the right answer, but there's more to do. If there's more that you can do, you should not stop. For example, this little piece of information, this SU is 3, SN is 11. That makes UN equal to 8. You might be like, oh, that's not who cares about that? But that actually is a really very relevant information, piece of information, because of the side splitter theorem. This is a side splitter theorem problem. This is a triangle split by a parallel side. When you have a triangle that's split by a parallel line. If you have a triangle split by a parallel line, then the two sets of split parts are going to be in proportion. So what does that mean in this case? SU over UN, SU over UN, which are the two split parts of SN, that's proportion is equal to the two split parts of SA, so SE over EA. And they love asking side splitter theorem question. Why is it called the side splitter theorem? Because two sides are split by a parallel line. So plug in some numbers here and letters. SU is 3 over UN is 8, and that's equal to SE, which is X, I'm going to call it X for now, over EA, which is 13. And I'm going to do the operation that students love, which is cross multiplication. 8x is equal to 3 times 13, which is 39. Divide by 8, divide by 8. This is not an arithmetic test. Again, we're going to go to the calculator to let the calculator do the arithmetic for us. If you let the calculator do 100% of the arithmetic for you on part 2, you get full credit. You'll see what I mean though, because you can't do too much and not show work. You have to write down. This is all you have to do. You have to write down the arithmetic that you're doing. Then you can let the calculator do the arithmetic for you. Divide by 8, and you get 4.875. x is equal to 4.875, and x is approximately to the nearest tenth, 4.9. And that is our choice. Groovy, right? I like it. Number 6. Many roofs are slanted to prevent the buildup of snow. As modeled below, the length of a roof is 5.5 meters, and it rises to a height of 2.5 meters. The angle of elevation of the roof to the nearest degree is 24, 25, 26, 24, 25, 27, or 28 degrees. So here's my angle, the angle of elevation, theta. So this is probably, I in every single problem I've ever done, almost every single problem I've ever done, I've been able to use process of elimination to eliminate some choices. This is probably the first problem that I really can't fully eliminate a choice unless I use correct prior knowledge. So I see that this is the hypotenuse. Okay. I know that high school geometry students aren't always used to using theta, so I'm going to use a letter. Let's call it x. So this is the leg opposite to angle x. So suppose you just didn't know, SOHCAHTOA, right? Then, but you did know a little bit of how to get the angle out of a ratio, which is sine inverse, cosine inverse, tan inverse. So I'm going to go to mode, make sure I'm in degree mode. Okay, enter. Okay, quit. I could go the inverse function, arc sine 2.5 over 5.5. I can go arc cosine or cos inverse 2.5 over 5.5. And then I can go arc tan 2.5 over 5.5. And then I get a 24 and change. And so one thing I notice here that's missing is 25 and 26. I'm sorry, 25 and 28. So supposing I don't know how to do the problem at all, other than getting the cos inverse out of it, I had to do something. Like I had to do some math because these numbers are so close together that I couldn't get away with just visually using scale. And this is drawn to scale, 2.5 to 5.5. But can I visually tell the difference between a 24-degree angle and a 28-degree angle? No, and that's the full range of angles here. So I can't use scale to eliminate any answers. However, I noticed that by doing this, I'm just missing I'm missing 25 and 28. 24 rounds to 24.4 rounds to 24, and 27.0 rounds to 27. So even then, I'm down to 2, and that's the only thing that I see that can eliminate some choices. But how to actually go about this problem? See how I wrote this? If you happen to know this, that this is the leg opposite to angle x because it is right on the opposite side of angle x, okay? Then you can say SOHCAHTOA, C over H, T O over A, S O over H, T C A over H, T O over A. And then if you write this, then that means that sine of x is equal to the leg opposite 2.5 over 5.5. So the correct one was the sine inverse. X is equal to sine inverse of 2.5 over 5.5, which according to my calculator is 27.03569719. Okay, so 27.03569179. That's a 1. Let me see. Yep. There you go. Okay, 9179. And then they set to the nearest degree. And so around 27 degrees. Okay, and that's my answer. Okay, so SOHCAHTOA, definitely for geometry class, is something that you want to know for at least 4 to 8 points. 4 to 8 points on the regions. On that note, número 7, number 7, in the diagram below, line CT is parallel to the line AR, and a line at ray ACE and segment RC are drawn such that AC is congruent to RC. If, and here's my diagram, and I'm going to make sure afterwards to make sure whether everything matches there. And then if the measure of angle ECT is 75 degrees, what is the measure of angle ACR? Is it 30, 60, 75, 105? I'm going to pause for a moment before giving you a piece of advice and say, suppose that you have no clue how to do this problem, but you decided to use scale because you trust what I'm telling you right now, which you should, by the way, that you could just use scale. They said, what is the measure of angle ACR? If you happen to know what an acute angle looks like, then you should be able to identify approximately at least what the measure of angle ACR is. And so that looks like a very small acute angle. And if it's a very small acute angle, then it's got to be 30, 60, 75, or 105. Actually, 105 is just entirely too big. Sorry, but I haven't addressed whether the diagram is drawn to scale or not. So that this would be where the X is. 75 is way too big. 60 is way too big. And this is looking good. That's assuming I didn't even analyze the question for correctness. So this is where assuming it's drawn to scale versus knowing it's drawn to scale are different. If I assume this diagram is drawn to scale, angle ACR looks like a tiny acute angle. 30 degrees is the only answer that's tiny acute. And you can walk away with a correct answer. However, you should actually do the work. So here, let's actually check. CT parallel to AR. This is drawn to scale because these definitely look parallel. And ACE, ray ACE, and segment RC are drawn. There's nothing, they're just drawn. Nothing contradicts the fact that they're drawn, such that AC is congruent to RC. I'm going to label them as congruent, but I'm going to note also visually they sure look congruent. So this is drawn to scale. And then the next part is that if the measure of angle ECT is 75 degrees, and that looks like a 75-degree angle. A right angle is 90 degrees. 75 degrees is really close to 90 degrees. This is drawn to scale. What is the measure of angle ACR? I've confirmed that the diagram is drawn to scale. Actually is 100% drawn to scale. Therefore, the arguments that I made, assuming that it was drawn to scale, now I can make them using the scale. This is drawn to scale, so the measure of angle CAR isn't 105, too big, isn't 75, too big, isn't 60, also too big. Scale, use it. So how do I actually do this problem? The way I do this problem is I use theorems that I've learned in the past. I have two parallel lines. The moment I have two parallel lines, I'm thinking corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, vertical angles are congruent, and then I'm also thinking same side interior angles are supplementary, same side exterior angles are supplementary, and adjacent angles are supplementary. And all of that will give me a ton of information. Since the measure of angle ECT is 75 and CT is parallel to AR, that makes the measure of angle CAR also 75 degrees. That's one. Okay. Then, because now there's multiple ways of doing this problem, and this is another thing I want to say. Geometry lends itself to multiple methods. So the method that I'm going to choose, they told me that these two line segments are congruent. I'm going to use isosceles triangle theorem. So if a triangle is isosceles, then the base angles of an isosceles triangle are congruent. So this is 75 degrees. Again, if a triangle is isosceles, the base angles are congruent. So that's a theorem. That's the isosceles triangle theorem. Which means that if I call this, I'm not going to use x for this one, just to get me used to writing as a student, writing angle ACR instead of just x. So I know that the sum of the measures of the angles in a triangle is 180. I could do the measure of angle A plus the measure of angle R plus the measure of angle C. No, I need to say ACR. That's equal to 180. And so I'm going to write 75 here, plus 75 here, plus the measure of angle ACR is equal to 180. I'm going to subtract 75, and I get, let the calculator handle the arithmetic for me, okay? I get 75 degree plus the measure of angle ACR is equal to 105 according to the calculator. I have one installed in my brain, that's why I did it in my head, but you should use the calculator. Minus 75 again, and I get that the measure of angle ACR is equal to 30 degrees. Exactly like we knew based on just scale. Groovy train. All right, so numero ocho, number 8. In the diagram below, the triangle ABC has medians AX, BY, and CZ that intersect at point P. If AB is 26, AC is 28, PC is 16, what is the perimeter of triangle CZA? Now, I am going to do a little bit of highlighting CZA, although I know you won't have a highlighter during the test. Okay? I just want to highlight it for the purposes of making a good video. Okay? So that's the triangle whose perimeter we're trying to get. How can you do that? You could do like a light tracing, or maybe even a dark tracing with your pen, or pencil rather. I'm going to label, I'm going to check for a scale. In the diagram below, triangle ABC, it is a triangle. So drawn to scale, has medians AX, BY, and CZ. This is where a little knowledge is required. However, if you don't have the knowledge, you could use your predicted scale to make estimates. But the thing that you have to know is that a median bisects the opposite side. Okay, so first off, before I even do that, because I said I would use process of elimination for every single question, let me label some lengths. AB is 26. Okay, AB is 26. AC is 28, and AC is a side of the triangle, so that's 28. So the perimeter is definitely going to be bigger than 28, but all these numbers are bigger than 28. PC is 16. Okay, and then they want the perimeter. Well, if C, so this is where I might make some estimates. If I'm gonna do, my little bit of guessing whether it's drawn to scale. So let's get the calculator out. If I assume that it's drawn to scale, then I see that AC is 28, plus PC is 16, plus a little bit P is ZP. And I can't tell how big ZP is, but it's shorter than PC. And this diagram so far seems to be drawn to scale. So if I just give a number to ZP, 8, half of 16. And then if I assume, I mean, it says median. I think that it means that Z is in the middle of BA. So if BA is 26, then ZA is 13. Then let's see what I get for I get 65. And that's actually an answer choice. That's making 65 look very good. So it turns out that what I just said is actually 100% correct. And I just made assumptions. So it turns out that ZA is congruent to ZB because CZ is the median. And a median is a line segment from a vertex to the midpoint of the opposite side. So Z is 100% the midpoint of the opposite side because they said medians. So that means that this is 13. This is 13. Okay? And so what is the perimeter of triangle CZA? Well, CZA, the perimeter of triangle CZA is equal to, now there's no estimates here, 16 from CP plus the extra piece that we're missing, PZ, plus ZA, which is 13, plus AC, which is 28, And so this is equal to, let the calculator handle my arithmetic, 16 plus 13 plus 28 is 57 plus CZ, no, plus PZ, okay? Making 57 100% incorrect because it's too small. But also, I see that PZ looks shorter than PC, which means if I make it max, if I make the maximum PZ to be 16, 57 plus 16 is 73. 73 is too big. So leaving 70 and 65 as the only correct answers. Now, there is a theorem out there that says that these 6 triangles inside of triangle BCA are, because they're made by medians, that all 6 triangles have exactly the same area. Since all 6 triangles have exactly the same area, and the sum of all 6 equal areas is equal to the area of triangle ABC, each area is 1/6 the area of the full triangle. So how can you get the area of, let's say, for example, just the little triangle PZA to be 1/6 of the full area? Well, we've already cut the base in half. And then what about the altitude? The altitude would have to be cut by 1/3. And 1/3 of CP would be ZP. And if that's 8, 1/3 of 24 is 8. Now, I know that CZ is not an altitude, but it has to, if that proportion is true for every, for the altitude, it has to be true for every corresponding line segment. And so that's a little trick that we could use. 1/3 of 24 is 8. So that length is 8. If we replace that with an 8, like we actually just guessed before, is 65. All right, number 9. In a right triangle ABC below, it is a right triangle. I'm going to start drawing the drawn to scale. So the next piece of advice that I'm going to give is actually that I would say label everything in the diagram as you are working. And I'm gonna say except for proofs, because there's a trick for proofs that allows you to eke out as many points as possible. Okay. So in triangle ABC below, it is a right triangle, drawn to scale, labeled right. So the measure angle C is 90 degrees. That's drawn to scale. AC is 12. There's nothing contradicting a single length. So that's drawn to scale. The measure of angle A is 25 degrees. Now, I know what a 30-degree angle visually looks like, and this 25-degree angle looks ever so slightly smaller than 30 degrees, so this is drawn to scale. Which equation is correct for triangle ABC? Is it that little a is right here? Is little a equal to 12 over tan 25? Or is little a equal to 12 tan 25? Or is little c equal to 12 over tan 25? Here's little c. Or is little c equal to 12 tan 25? And this is where a student who struggles but recognizes that they confirmed that it's drawn to scale. We just confirmed that it's drawn to scale. If you assume that it's drawn to scale, then you can only use your assumption. But if you confirm that it's drawn to scale, then everything that you said based on scale is 100% true. Again, what's the difference? If you assume that it's drawn to scale, then you're hoping that it is drawn to scale. And so that your assumptions you're hoping are, or the calculations under that assumption, you're hoping that they're correct. But if you know that the thing's drawn to scale, then those calculations that you did have to be correct. Either way, using scale works. Notice that we haven't run into a diagram where using scale is a bad idea. And we're already at number 9 out of 24 questions. We are more than a third of the way through the multiple choice. Tons of drawn to scale benefits. Okay. So what would I do if I'm struggling with this question? I would say BC or little a looks like half of 12, half-ish of 12, and little c looks a little bigger than 12. So if I actually start plugging in numbers, 12 over tan 25, that's like 25. That's got, little a is not double 12. It's around half of it, maybe. So then if you do the same thing for, I'm going to put the rest of these, 12, 12 tan 25. Now we can't just stop once we get an answer that looks reasonable for us. 5.59 for little c, so 5.59. That seems reasonable. We said that that little a might be around half of 12. We can't compete with that yet. But then little c is equal to 12 over tan 25. We've already calculated 12 over tan 25. This is around 25. That means that little c would be double 12, which we already said little c is only a little bit bigger than 12. This is too big. And actually little c is equal to 12 tan 25. We already calculated this, 5.59, which we know that little c is the hypotenuse, and it has to be strictly longer than 12. We actually just use scale to confirm the answer. Now, how can we do this using complete algebraic math as opposed to using scale to confirm the answer? We could use SOHCAHTOA. So, and I want to point out here, we are now in the realm of the new geometry regions. These are the next gen standards compared to the Common Core standards that we were using literally just last year. We already see that we've used SOHCAHTOA on multiple problems. On the past regions, I used it maybe once, sometimes twice. And sometimes if it was like a third time, I could actually technically avoid it anyway. So it's clear that SOHCAHTOA is super relevant. The definitions of sine being the opposite leg, the leg opposite to your angle divided by the hypotenuse, the cosine being the measure of the adjacent leg to the angle divided by the hypotenuse, and then the tangent of an angle being the length of the opposite leg over the length of the adjacent leg. That's a super necessary piece of information, SOHCAHTOA. So little a, if I'm going to use this and the 12, so this is the leg adjacent to the 25-degree angle. And this one is the leg opposite to the 25-degree angle. And this is the hypotenuse. That's what also made me think that choice 3 and choice 4 were incorrect. None of them talked about the hypotenuse because they didn't talk about sine and cosine. But that said, I see that we have the opposite, the leg opposite being used, that's O, and the leg adjacent being used, that's A. The only one that uses O and A is tangent. So tan of 25 is equal to the opposite leg, A, over the adjacent leg, which is 12. And if I solve for A using the favorite cross multiplication that students love, cross multiplication, A times 1 is equal to 12 tan 25. So A times 1 is A, equals tan 12 tan 25, exactly as choice 2 says. Groovy. Numero 10, number 10. Triangle HUS is shown below. Here's a triangle, HUS. If point G is located on US and HG is drawn, which additional information is sufficient to prove that triangle HUG is congruent to triangle HSG by SAS? So they tell you that they have to be congruent, and they tell you it has to be by SAS. So it has to be on. So it has to be on US. So I'm going to call this G, and I have to make congruent triangles, which is what made me. Okay. I'm not erasing that because I'm not doing any edits to this video. Here's point G. I made it right at the center because again, it has to, the triangle has to be congruent. So this is one of the few examples, like I was saying, drawn to scale. Technically speaking, this diagram has a ton of flexibility, but now they're forcing us to draw something into the triangle so that the triangle is guaranteed to be split into two congruent triangles, which means I'm going to use this, and I'm going to assume that the triangle is fairly rigid, but what assumptions do I have to make? Okay. So let's see what is true. Right now, I don't have any additional information. All that we have is that point G is drawn. Let's see. If they say that HG bisects US, so I'm going to start labeling this one in blue. HG bisects US, so that is congruent to that. Remember that the diagram is technically flexible. If these two segments are congruent, is that enough to prove SAS? Well, this does not force any angles to be anything, have any relation with each other. Not yet. The next one, I'm going to draw in red, that HG is an altitude. That makes, I'm going to erase the blue now, because now I don't know that because I'm working on why is that not erasing? Because I'm working on choice 2, okay? So on choice 2, HG is an altitude. That makes this perpendicular. That gives me 2 congruent right angles. So now I'm looking for SAS, but now I just have angle. I have angle. And I have side. I should actually say that we have a side for choice 1 too. We had a side, and we had a side, but we didn't know that those two angles would be congruent. But now for choice 2, we have a side HG congruent to itself and an angle, the 2 right angles. But we don't have the second pair of sides because these aren't guaranteed to be congruent right now. So now we go to choice 3, that HG bisects angle HUS. So now we have that angle and that angle congruent. Now we have angle and we have a side, but there's nothing forcing. Remember, these two angles being these two angles being right was part of choice 2. We don't know that for choice 3. So now we have an angle and we have a side, and that's all we not have. We don't have side, angle, side. So that's not it. So now we erase those marks. During the test, you shouldn't erase the marks, but for purposes of clarity, I'm erasing them. Now, the last one is choice 4, which I'm going to draw in blue also. HG is the perpendicular bisector of US. Now, there's something about choice 4 that actually causes us to eliminate choice 1. HG bisects US versus HG being the perpendicular bisector of US. Being the perpendicular bisector is a strictly stronger statement than being the bisector. So if choice 1 would be the answer, that would imply that choice 4 is also the answer, which can't be. So choice 1 can be eliminated. How about HG being the perpendicular bisector of US? Now these are perpendicular, which gives us a pair of angles being congruent. Right angles are congruent. And also the bisector, which means that that segment is congruent to that segment. Now we have a pair of sides, SG congruent to UG, SG congruent to UG. And we have the measure, that angle UGH is congruent to angle SGH. So that's side. And we have angle. And then side, HG congruent to itself. That's the side. And so that means that choice 4 is the answer. And we did use process of elimination to eliminate one of the choices if we didn't know how to do it. Every single question, that's my goal, to have some process of elimination for every single question. Number 11, the area of the base of a cone is 9 pi square inches. The volume of the cone is 36 pi cubic inches. What is the height of the cone in inches? So we do need information about a cone. I'm going to pull out the Regents right now. I'm going to scroll all the way to the bottom and look for the formula sheet. Okay. There is information about the volume of a cone right here. That a cone's volume is 1/3 pi r squared h. And you do need to know that information, and you do need to be willing to go into the back of the test and get formulas. Okay? So, now there is another formula that if you're clever, let me see. Oh, it used to be on the old test. There we go, pyramid. Any pyramidal shape, including pyramids with circular bases, also known as cones, have satisfy this formula. So you could have done it with this formula, and that's actually how I visually imagine it, because the base of a cone is a circle. Okay, so we have a cone. The base of a cone is a circle with area pi r squared. So we have a radius r, and the area of the base is equal to pi r squared. And so we see that matches here. Okay, but let's see. The area of the base of a cone is 9 pi square inches. The volume of the cone is 36 pi cubic inches. What is the height of the cone in inches? So if I were if I were to try to make some process of elimination happen, suppose like I just couldn't see the area of the circle or in the formula. If I were to do some process of elimination here, I might say, well, I know that the area of the base is 9 pi. What if it weren't a cone? What if it were just straight up, which would make it technically a prism or a cylinder? And then for it to have a volume of 36 pi, the height would have to be 4. But because the cone tapers, the height has to be greater than 4. So again, if I have a base of 9 pi, then a height of 4, the volume is equal to 36 pi, which means that this one has to have a height is greater than 4, which eliminates choice 3 and choice 4, which is nice. I mean, that's a piece of process of elimination that I would definitely use. But how do I go about the problem? I know that the area of the base is equal to pi r squared, and so the volume is equal to 1/3 pi r squared h. Here, the area of the base is pi r squared, which is equal to 9 pi. I substitute pi r squared with 9 pi, and I substitute v with 36 pi. So 36 pi is equal to 1/3 times 9 pi times h. Okay? And I want to teach you how to do the arithmetic on paper, but suppose I just really struggled with the arithmetic on paper. If you just remember to use parentheses on the test, you could just do this on the calculator. You'd have to trust the calculator, unfortunately, but which is not always the best. But if you do 36 pi divided by 1/3, and then also I have to divide by 9 pi. So I'm going to divide by 1/3 times 9 pi instead of just dividing by the 1/3. Might as well if I need to use parentheses, right? So divided by 1/3 times 9 pi, and I just remember to use parentheses. 1/3 times 9 pi, close the parentheses, I get 12. Remember, you just on the test, all you have to do is write the arithmetic that you're going to do, and you get full credit. So h equals 12. And that's a part 2 question. On the part 2 question, you could write the arithmetic and you get full credit. Okay. Numero dos, number 12. On the set of axes below, A, B, C, D, E, F, G, H, and I, J are drawn. Yeah, sure they are. Done. That's technically drawn to scale because they're just drawn. Which segment is the image of AB after a dilation with a scale factor of 2 centered at -2, 1? So this diagram is drawn to scale because there's nothing that can be contradicted. Here's -2, -1. Okay. So how can I go about this problem? What I do in this case to figure out if it's drawn to scale, I pull up my straight edge, which you're required to be allowed one during the test, and I draw a straight line from the center of dilation to B. Straight line, which means I actually extend it. I keep going, okay? And I go in the other direction as well, okay? And then I do another line segment from the center of dilation through AB, through A in one direction, and then I keep going also in the other direction, okay? And now I can see that GH is not even a dilation of AB centered at -2, -1. GH is probably a dilation where maybe you wrote down the wrong coordinates or something like that. Maybe. Oh, if you dilated from the origin. Yeah. But anyway, so GH is not a dilation of AB with a scale factor of 2 centered at -2, -1, because it's not a dilation of AB centered at -2, -1 at all. So that's wrong. Okay. Now, which one of these can be the answer? I also see that CD is not a dilation of AB centered at 2, 1 because C is not on the blue line segment. So CD can also be eliminated. So now with process of elimination, I've turned this into a passing problem. I haven't yet talked about what a passing problem is. So I'm going to talk about what a passing problem is now. I know that one of the reasons that teachers tell you to focus on the multiple choice is that you basically need around half the multiple choice to pass the test. You need about half the multiple choice to pass the test. And so this is the grading scale for passing the test. If you get all 80 points, you get 100. And if you get 0 points, which is nearly impossible, since wild guessing on the multiple choice gets you a grade. But if you get nothing on the test, you get a 0. So for example, if you invalidated the test, or you even left the multiple choice blank. However, statistically speaking, if you don't even read the questions and you wild guess, on average, you'll get 6 out of 24 questions right, and that's a 12. Notice that that's a 35. So if you get anywhere near 35, it means that your score is really very close to what the wild guessing would give you, which is why I'm actually doing a lot of strategies to eliminate incorrect answers, because that wild guessing gets a lot better once you start to be able to eliminate a ton of just incorrect answers, sometimes eliminating all the incorrect answers. Here's the thing. To pass this test, you need 32 points. 32 points. Each multiple choice is worth 2 points. That means you need, if you did nothing on the part 2s, 3s, and 4s, you need 16 multiple choice questions, right? But there's a couple of things. First off, that's too many points to just focus on the multiple choice and hope you're going to pass. It's too many points to focus on the multiple choice and hope you're going to get an 80, or to hope you're going to get a 90. You can't even get a 90 if you just focus on the multiple choice. If you get every single multiple choice question right, you got a 48, which goes to a 76, rounds to a 76. You don't even get an 80 if you don't do the part 2s, 3s, and 4s. Now you're fighting against luck, because you're talking about perfect multiple choice 48, passing multiple choice 36. That's too many. That's too many. I'm sorry, 32 to 48, that's too many. That's in fact 16 multiple choice questions. However, what do I call a passing problem? A passing problem is a problem for which you've eliminated 2 of the incorrect choices. Why do I call it a passing problem? After all, well, the reason is that if you take every single multiple choice question and by some miracle eliminate 2 out of the 4 choices, which by the way, we've done for almost every single question so far. One of the questions we eliminated 1 choice, but many of the questions we've eliminated all 3 incorrect choices. So we've done even better than eliminating 2 choices on average. If you eliminate 2 choices on average, then on every single question, then on average, after that point and you wild guess, you get half of the 24 questions right, which is 12 out of 24. Yes, you need 16 out of 24 questions. You need 8 points total. But then if you eke out a few points using correct math on the part 2s, 3s, and 4s, and you get some correct answers on the multiple choices by doing correct math, then you really do only need about half the remaining multiple choice questions. So a passing problem is a problem in which you've eliminated 2 of the wrong choices. So a passing problem is equal to a problem in which you've eliminated at least 2 incorrect choices. So notice a passing problem is defined for multiple choice questions. A passing problem for the part 2s, 3s, and 4s is any question in which you get at least half the points, which we're going to talk about ways to do that too. So here, how do I do this problem? Other than I've eliminated 2 choices, how do I do the problem now? I could actually kind of see that the center of dilation, which I'm going to call Q, from Q to B, twice that distance is about Q to F, and from Q to A, twice this distance is about from Q to E. So EF is looking very good to me right now because it's a dilation of a scale factor of 2. Okay, but how do I actually confirm that? This is where I actually do the problem now. I do the x coordinate of Q. I'm going to choose the x and y coordinate of B and F. I could do the same thing to check my answer at A, or if it's a part 2 question, I could do exactly what I'm doing right now to generate the coordinates of F and E. So, and because what I'm doing right now is generating the coordinates of A, of F. Do the same thing to generate the coordinates of E by dilating A. So if I do the x coordinate Q, the x coordinate is at -2. The x coordinate of B is 2. The x coordinate of F is some mystery number. And the y coordinate of the dilated point, the y coordinate of Q is -1. The y coordinate of B is 1. And the y coordinate of F, I shouldn't actually say F at this point because I realize by naming it, I'm already assuming the answer is F, which I happen to know that. I'm going to use B prime as the image. That's more correct. So that I'm getting the x coordinate of B and B prime. How do I get those x coordinates? Well, I know that from Q to B, to get from Q to B, I have to add 4. -2 plus 4 is 2. If you don't believe that, or if you don't know what number you have to add to -2 to get to 2, guess and check on the calculator to get to it. So to dilate by a scale factor of 2, I have to add 4 times 2, which is equal to 8. So I have to add 8 plus 8. -2 plus 8 on the calculator. Again, get used to using the calculator for all your arithmetic. Move that away. Sorry. There we go. Okay. -2 plus 8. So -2 plus 8 is 6. And also -1 plus 4. Sorry, I went too far. Plus 2 here. So I have to add 2 times 2, or I could do plus 2 plus 2, or plus 2 times 2. Or here I was doing plus 4 plus 4, right? Plus 2 plus 2, -1 plus 2 plus 2, or -1 plus 4. I like doing the plus 4 instead. So -1 plus 4 is 3. So I got the x coordinate is 6, the y coordinate is 3, and the point that has x coordinate 6 and y coordinate 3 is point F. So that's the dilated image of B. So the answer has to be EF. And I would do the same exact math to dilate from QA to get point E if this was a part 2 question. All right, let's get a little sip over here before we move on to number 13. Fairlife, call me. All right, trapezoid ABCD is graphed onto the set of axes below. And this does look like a trapezoid, ABCD, so this is drawn to scale. I see that BC is parallel to AD, so this is drawn to scale. Which transformation would map point A onto point A prime 3, -7? Okay, so this is 3, and this is -7. I didn't just guess there, by the way. 1, 2, 3, 4, 5, 6, 7. I just happen to be able to visually count to 7 fairly easily, just visually. So this is going to be A prime. Okay. I definitely, to do this question, I mean, you tell me, do you think that writing down the X and Y coordinate of A is beneficial? Probably, right? So I've seen students not even bother with that. So they, 1, 2, 3, 4, 5, 6, -7, and 1, 2, 3, 3, -7, 3. So I have to do an operation to act on -7, 3 to get to the point 3, -7. Now, if I happen to know some of the formulas that do choice 1, reflect over y equals x, or choice 2, reflect over the y-axis, or choice 3, rotate 180 degrees about 0, 0, or choice 4, rotate 90 degrees counterclockwise about 0. If I happen to know any formulas that do that for me, then I can confirm whether those answers are right or wrong. But if I didn't know the formulas, but if I knew what reflecting over the y-axis is, reflecting over the y-axis, here's the nice good old y-axis here, right? Here's the y-axis here, right? So I'm going to reflect over that. I got to flip A to on the opposite side. Here's I'm going to say A2. A2, why A2? Because that's choice 2. So that's not it. 100% sure that's not it, because that's not A prime, nowhere near it. Now, how about reflection over the y equals x? That's looking pretty okay to me. I'm going to actually go ahead and graph the line y equals x to help me visually. Just missed it. Okay. Yeah, to help me visually. I have to reflect over this line, so something like that. And even just doing this, I'm already crossing A prime, so choice 1 is looking nice. Now, how about like a rotation by 180 degrees counterclockwise? If I have a circle and I rotate 180 degrees, it has to end up on the opposite side of the origin. So if I actually draw a line segment through the origin, the same length from 7, 3, from -7, 3, I have to get to the rotation 180 degrees. So this is A3. So this one's also incorrect. Now, the ones that I might be struggling, and so that's the one that I would normally struggle with, but because it's in the same quadrant, A3 is in the same quadrant as A prime, but I see that drawing a line right through the origin gets me to a different point than A. Now, a rotation of 90 degrees counterclockwise, about 0. 90 degrees counterclockwise, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Rotating 190 degrees counterclockwise takes quadrant 2 to quadrant 3. But A prime is in quadrant 4. So choice 4 is actually incorrect. And so I used process of elimination to eliminate all of these choices. So how could I actually though confirm that the answer is y equals x? One thing I could do, that line segment that I drew, if I draw a line from A to A prime, a line segment from A to A prime, notice that it's actually perpendicular to the line y equals x, which is emblematic of reflecting over the line y equals x. Notice also that these line segments are actually identical from this point. I'm going to call this point P. AP has, to get from P to A, you go to the left 5 and up 5. To get from P to A prime, you go down 5 and to the right 5. So PA prime and PA have the same length. So this, in fact, A prime is a reflection over the line y equals x. That's how I confirmed it, okay? Number 14, a storage building is modeled below by a hemisphere on top of a cylinder. The diameter of both the cylinder and the hemisphere is 12 feet. The total height of the storage building is 30 feet. To the nearest cubic foot, what is the volume of the storage building? Is it 942, 2488, 3167, or 3845? One thing to know about how test problems are constructed, when I was younger, they, the makers of tests, no matter what the test was, they knew that like higher level students would do things like just estimating the answer and used estimates to get the answers right. And so what they would do is they would give choices that were close to the estimate, but yet couldn't be arrived at via correct math. They were just close to the correct answer so that you couldn't use estimation to guess the answer. Mathematicians, test creators really, moved away from that policy because it wasn't a good policy. Um, it was better to create answers that you could arrive at via commonly performed incorrect methods. Because what we're trying to do is test you on your methods, right? But what did that do? What that did is it made the choices end up being farther from the correct answers. So what does that mean? We can actually do correct math to make estimates for the volume. And if that correct math puts bounds on the correct volume, then you can use that correct math to make your estimate itself. So here's an example. Suppose I really struggle with compound figures. I'm going to use correct math here to estimate the volume and eliminate some choices. What if the volume, instead of being a nice cylinder with a nice hemisphere top, what if it was just a cylinder? Okay? Notice the cylinder completely contains our volume, but has this just tiny bit of extra volume. So the volume is less than the volume of the cylinder, but only by a little. So in fact, if I get the volume of that big cylinder, I eliminate a lot of choices. So the volume of the cylinder is equal to pi r squared h according to the test formula sheet, right? Remember the formula sheet here. V equals pi r squared h. Where's the cylinder formula? I'm going to put that right here. Okay. According to that cylinder formula, V equals pi r squared h. And this cylinder volume is equal to pi times, now I do have to know that if the diameter is 12, that the radius is 6, pi 6 squared times, now the red cylinder's height is 30. So we have that the volume is less than, well, now they wanted an integer. So let's get that. Pi 6 squared times 30. And we get 3392. 3392.0920066. 920066. So V is slightly less than 3393. Slightly. So look, 3845 eliminated because it's too big. It's actually just bigger than a container containing the volume. 942, so this is too big. 942, remember the volume has to be slightly less than 3393. That's eliminated. It's too small. Too small. It has to be really close to 3393. So now 3167 and 2488 depends on my definition of close. But I see that most of that volume is contained in that bottom cylinder, which matches the actual volume V. So it's only a little tiny bit and only at the tippity top. So this is probably too small. 24 compared or 25 compared to 34. And then this is like 31, 32 compared to 34. So 3167 is looking very nice to me. How do we go about doing this problem though? Because we have to be able to do it using correct math. And I promised you that I would show you how to do every single problem using correct math. This radius is 6 again, which means that the radius of the hemisphere is also 6, which means that the radius of this blue part of the cylinder is 30 minus 6, which is equal to 24. So the volume is equal to the volume of the blue cylinder plus the volume of a hemisphere. And a sphere, we have to know the formula of for the volume as well, the formula relating the volume to its radius. Here's the formula relating the volume of a sphere to its radius. It might be an awkward formula for you if you've never seen it before, but we're going to put it here, okay? And we're going to use it. And remember, it's a hemisphere, it's half a sphere. So the volume of the blue cylinder is, pi r squared h, okay? Pi, radius is 6 squared times the h for the blue cylinder is 24, plus the volume of the hemisphere, it's a half a sphere, so half of 4/3 pi times the radius, 6 cubed. And this might be scary for you. You're like, wait, I can't do this. You don't have to. Cool. So you don't have to. So you don't. Like, don't. I wish you could do this on paper. I wish you could do that arithmetic on paper. That is a wish that I have for you, but oops. But since this is a Regents test, and this is not, I'm not training you right now to be good at math exclusively for the sake of being good at math, but actually I'm training you to be good for the Regents. I'm gonna re-emphasize using the calculator. So pi, they want a integer answer. So pi 6 squared times 24 plus 1/2 times parentheses 4/3 times pi times 6 cubed. And we get a number. 3166 3166.725395, which is around, and then they said to the nearest cubic foot. This 7 causes the previous 6 to round up to a 1 above 7, so 3167, which we said the other one was probably too small, and we were actually right. Look at that subscribe button. I said that I would talk about the Fairlife. I don't know if I added a section for snacks. I don't see that I did. So I'm going to talk about snacks now. And I want to be brief about it. But if you want to skip forward to the problem, go ahead and skip forward to the problem. But I do want to just briefly talk about it because I want to be as complete as possible. What kind of snacks should you be bringing to the test? You shouldn't be bringing any snacks that bother your stomach. And that's why one of the reasons I actually recommend Fairlife. It's a lot of different reasons. Fairlife is lactose-free milk. And even if you're not lactose intolerant, lactose just takes longer to digest. And some of the lactose does make it to your belly, to your intestines. And when it does that, it feeds bacteria that causes you to have to go to the bathroom. And you don't want to have to go to the bathroom in the middle of a test. You want to be able to hydrate during a test, but you also don't want to get so thirsty that you start running out of you start running out of patience and you have to go to the restroom. So Fairlife is just a small volume of liquid, and it'll keep you not dehydrated. So the next thing that I recommend as a snack, a pure protein bar. This has very little fiber. Normally speaking, if I were a person recommending to you a fiber supplement or like a healthier snack, this wouldn't necessarily be it. If I was recommending like a weight loss snack, maybe, but you'd have to talk to a dietitian to see what's best. But the fact that this doesn't have a lot of dietary fiber and it has, unfortunately, a little bit more sugar than I'd prefer, but the fact that it has the sugar is a good thing. It gives you sugar. for energy, but it's also kind of difficult to eat. It's actually chewy, so uh, you're not sitting there it's like getting a giant sugar rush followed by a crash. You could eat this very slowly and you get your energy little by little. And also because it has a very small amount of fat and no lactose, then that's another snack that doesn't affect your digestion. About coffee, yes or no? My philosophy is if you are a coffee drinking professional, I'm 42 and I'm a coffee drinking professional, then go ahead and drink coffee. But if you are not a coffee drinking professional, you might be surprised that drinking coffee is actually worse for you than not drinking coffee. Um, if you're not a coffee drinking professional, but you super insist on drinking coffee, go for decaf. Uh, Decaf does not mean caffeine free. Decaf has caffeine in it, but it has also a small amount of caffeine. And if you're not a coffee drinking professional, that little bit of caffeine does wonders. Okay, if you like milk in your coffee, I would go for a lactose free milk, like Lactaid, and put as much sugar as you prefer in your coffee. But also don't take a lot of it because that might make you go to the bathroom. I recommend coffee with a little bit of milk over, let's say, for example, Diet Coke or Coke, because the sodas are diuretics and they make you go to the bathroom. So that you'll drink soda, but you'll actually have to go to the bathroom more quickly. So I recommend coffee with lactose-free milk. That's my end of the snack spiel. If Fairlife or Pure Protein wants to contact me to sponsor me, I would definitely take the sponsorship. But none of this was sponsored. The only sponsor for this video is me myself, JuanTutors.com. So, numero 15, number 15, which regular polygon will carry onto itself after a 135-degree rotation about its center? A triangle, a pentagon, a hexagon, or an octagon? They love asking this question, so I would assume that there's about a 70% chance that they're going to ask it. And starting with a triangle, okay? This is a regular polygon. So starting with a nice, easy triangle, if I rotate a triangle onto itself, that's some mystery number of degrees, right? But if I rotate it again, that's some mystery number of degrees, and that's the same mystery number of degrees. Notice I did that. I'm going to call this t for turn, t for turn, t for turn. 3 turns is equal to a 360-degree turn, so I have 3t is equal to 360. And if I divide by 3, I get that 1 turn is equal to 120 degrees. Okay? Now, that means that I could rotate a triangle by 120 degrees and rotate it back onto itself. That's not 135, but it's also less than 135. So technically, I have to go for a second turn. 2t equals 240, and that's just bigger than 135. So it's not a triangle. But notice that by doing this first problem, just to get me some intuition on the problem, I've already got the method that gets me to the correct answer. Because if I go for a pentagon, this has to be a regular pentagon, okay? Here are my vertices, just to make it clear, because this is a little sloppy-ish. If that's a turn, that's another turn, that's another turn, that's another turn, and that's another turn. Identical turns, five identical turns, and all 5 turns add up to 360 degrees. And so if I divide by 5, I get that 1 turn equals 72 degrees. And how did I do that? I did that on my calculator. So if 1 turn is 72 degrees, that's less than 135. So technically I have to go for a second turn. And that's 144, which is greater than 135. This is less than 135. I completely skip over 135, so it's not a pentagon. Let's go for a hexagon. Let's go for a hexagon. A hexagon has 6 sides, and an octagon has 8. So now, actually, I'm starting to get the formula. I might be able to actually just write down the formula. So for a hexagon, 6 turns ends up right back to a full turn is 360 degrees. And if I divide by 6, then I get that the number of turns the number of degrees in a single turn is 60 degrees, which is less than 135. So I have to keep going. 2 turns is equal to 120 degrees, which is still less than 135. 3 turns is equal to 180 degrees, which is greater than 135. So it skips over 135, so it's not a hexagon. And just to confirm that it's an octagon, 8 turns has to go right back to 360 degrees, which is back to the original position. So 8 turns adds up to 360 degrees. If I divide by 8, I get that 1 turn is equal to 45, according to my calculator on my computer or in my head, you know. You should do the arithmetic on your calculator if you struggle with arithmetic at all. 2 turns is 2 times 45, which according to my calculator is 90, which is still less than 135, and this is less than 135. So 3 turns is equal to 3 times 45, which is equal to 135, which is actually the number of degrees that they were talking about. So the answer is an octagon. On that note, there's another subscribe hint. Why do I ask you for subscribes, by the way? Why does every single YouTuber ask you for subscribes? That's a lot, right? Well, subscribe, right? Well, here's the reason. Well, if you get to 1,000 subscribers, which this thing will tell you, I'm already at 1,000 subscribers, but also if you get a certain number of hours of views every 365 days, then you could actually put ad revenue in the video. And one of the reasons why I create these videos is to provide a free service to people, because I know that, again, JuanTutors.com, I have a lot of tutors working for me, including myself. I'm the owner of JuanTutors.com. I tutor very discerning clients, and very discerning clients are very demanding. But because of that, I'm able to charge a higher fee that they can handle. I know that I've priced myself out of a lot of people's budget, so I provide this service for free. One, to advertise myself, but two, to just give a free service to people who can't afford services with me. Maybe though you can afford services with one of my other tutors. So if you do want to check out JuanTutors.com, I do recommend it. I have great tutors working for me. But the thing is that once we get to that point with the 1,000 subscribers, which it showed I have over 1,000, but I don't have yet the 4,000 hours of views in a single year. Once I get to that point, I can put ad revenue, and then these videos get paid for, which is great. That's kind of part of it. Okay, so this one, número 16, number 16. What is the length of the radius of a circle whose equation is x squared plus y squared minus 2x plus 4y minus 5 equals 0? What is the radius? This could easily be a part 2 question. They might ask for the center and the radius. So keep in mind, this is a piece of relevant information. Do I have a way of eliminating an answer? I do. So I remember the equation of a circle. Let's check the Regents to see if they have the equation of a circle. Let's see. They have the Pythagorean theorem, but they do not have the equation of a circle. So that's the second equation that we've discovered that we need that they don't have. The first equation was the perimeter equation. They don't have a single, other than a circle, they don't have a single perimeter equation. But all that the equation for a perimeter is, perimeter equals the sum of the lengths of the sides of a shape. Done. The lengths, add up the lengths of the sides of a shape, that's the perimeter. That's every single, the triangle, rectangle, square, parallelogram, trapezoid, regular octagon, irregular octagon, every single one. Add up the lengths of the edges, that's the perimeter. So this one, Pythagorean theorem, is reminiscent of the formula for the circle with a center and a radius. So, but we have to know this one. Equation, if you happen to know this equation of a circle with center h comma k, wherever, maybe like 2, 3, maybe negative 1, 4, whatever, somewhere is the center of the circle, and radius r, the equation is x minus h squared plus y minus k squared equals r squared. That's the equation of a circle with center hk, radius r. Okay? So if I happen to know that, then I might say all these numbers are very small. So to have a radius of 10, r squared equals 100. 10 squared is 100. Here r squared equals 25. Here r squared equals 10. And here r squared equals 5. And so one answer that I suspect is wrong is 10. I suspect that if no matter what I did to this problem to get it in this form, x minus h squared plus y minus k squared equals r squared, that I'm not going to be able to get 100 on the right side of the equal sign. There's another answer that I'm going to confirm is wrong in a second. If I take this equation and add 5, this is actually now in the process of solving it, but I'm going to also show why this eliminates a choice. Plus 5, and I get that x squared, and I'm going to use the associative property to combine the x parts and the y parts separately. X squared minus 2x, big blank, plus y squared plus 4y, big blank, equals 5. Now I'm in the process of solving it. Just want to be clear. But why do I eliminate choice 1? Because now I know that I'm going to be adding numbers to the left and the right side. If I add numbers, positive numbers, to the right side, then that side is going to get bigger than 5. The square root of 5 is radical 5. That would be the radius. But if I add numbers, positive numbers to 5, I'm going to get a bigger value of r squared, which means that r is going to be bigger than radical 5, since r squared is bigger than 5. Okay, so the answer is either 10, radical 10, or 5. And I've created a passing problem, by the way. I clearly see that I'm also not going to be adding 95 to the left and the right side. So me, personally, I'm comfortable with crossing out 4, but you as a student may not be comfortable may not be comfortable crossing out 4, so I'm going to leave it. So how do I solve this? Step 1, I gather the x's together, I gather the y's together, and I leave a big blank in between, and now I got to complete the square. Okay? And on the x direction, I'm going to make an x column and a y column. All right, b equals the coefficient of x, -2. b over 2 equals, well, -2 over 2. Use the calculator, -1. And b over 2 squared. Use the calculator and use parentheses. -1 squared is -1 times -1 is +1. So I'm going to put a +1 here and a +1 here. Why I'm doing that? It will be clear in a second. In the y direction, b is the coefficient of y is 4. b over 2 equals 4 divided by 2 is 2. And b over 2 squared is equal to 4. So I'm going to put +4, +4. And let's just quick summarize here. What did I do? I got my b over 2 squared for x, and I added it to both sides. Then I also got my b over 2 squared for y, and I added that to both sides. Here's my +1 that I added to the right side, and my +4 that I added to the right side. Now I simplify a little bit. Okay, so now I have x squared plus 2x minus 2x minus 2x plus 1 plus y squared plus 4y plus 4 equals 10. Okay, now can I use the highlighter, a different color highlighter? Will it let me do that? Yes, good. Now I'm going to use this number, the b over 2, to actually factor the completed squares. So x squared minus 2x plus 1 is a completed square, and x squared plus 4x plus 4 is a completed square. I'm going to use the green numbers to complete that square. I have x, now minus 1, that's the b over 2 squared, plus y, parentheses y, here's the b over 2 plus 2 squared equals 10. And this is the equation of the circle. So where did these numbers come from again? Here's the -1 under the x column, the b over 2, and here's the +2 under the y column, the b over 2. Okay, and so now the center is equal to x minus h. So I'm subtracting the x coordinate, subtracting 1, and here I'm subtracting the y coordinate, subtracting 2 to get +2, so subtracting -2. And the radius, r squared, is equal to 10. And so take the square root, I get r squared plus or minus technically, but reject negative radical 10 because r is greater than 0. Our radius is always greater than 0. R is equal to positive radical 10. And that gives us the answer, choice 2. And we did this exactly how a part 2 question could be done. Número 17, number 17. The line represented by the equation y equals 4x plus 15 is dilated by a scale factor of 2 centered at the origin. Which equation represents its image? Y equals 4x plus 15, y equals 4x plus 30, or y equals 8x plus 15, or y equals 8x plus 30. This test loves to ask this question and another variation of the question. One question that it loves to ask is like dilating a line through a point that's on the line, which doesn't change the line, so the equation stays the same. And the other one is dilating a line through the origin, which doubles the y-intercept and doesn't change the slope. One thing to know is that dilations do not change slopes, and that's an important thing. Dilations, and we saw that in the other example that we'd had, where we had like 5 different line segments in that diagram, all dilations somehow, but not all of them were dilations from the same points, but all of them were parallel. Dilations preserve parallelism. Dilations preserve parallelism. Parallelism. And therefore angles, okay? I just added angles because, so you know for forever. But dilations preserve parallelism, which means that the line, the dilated line, so if you call this L and call this the dilated line L prime, so then the slope of L is equal to the slope of L prime. So 4 is equal to the slope of L prime. So that means that this has the correct slope, this has the correct slope, this has the wrong slope, this has the wrong slope. So choice 3 and choice 4 are not the answer. We now have a passing problem. Passing problem. All right. So how do I get the answer? Well, I can also do process of elimination just to add an extra piece of process of elimination. If I have 4x y equals 4x plus 15, I have this line here. So there's the y-intercept 15, and this is dilated by a scale factor of 2 centered at the origin. Okay, if that's a distance of 15 away, and I scale factor of 2 double that, 15 times 2 is 30. Okay, and so the y-intercept is going to be 30. So that one has the correct y-intercept, but it's this one that has the correct slope and the y-intercept, correct y-intercept. I haven't gotten to a 2x2 problem yet, and this is a 2x2 problem. So let me talk about what I call a 2x2 problem right now. You don't have to draw the diagram that I'm going to draw for a 2x2 problem, but number 18 happens to also be a 2x2 problem. So I'm going to talk about it. Number 18, line segment RH has endpoints -4, 4, and H, R -4, 4, and H 2 -4. Which equation represents a line perpendicular to RH that passes through the point 3, -1? Is it y plus 1 equals 3/4 x minus 3, or y plus 1 equals -3/4 x minus 3, or y plus 1 equals 4/3 x minus 3, or y plus 1 equals -4/3 x minus 3? So what is a 2x2 problem? A 2x2 problem is a problem that has 4 choices in it, but it differs 2 different things in exactly 2 ways. So notice that the only things that change here, if you look at these 2 problems, the only things that change here are whether the slope has a plus or a minus in it, and whether the slope has a 3/4 or a 4/3 in it. So if you make a table one with a positive slope, one with a positive slope, and one with a negative slope, and one with a 3/4, and one with a 4/3 in it, then you have all the choices. And the ones with a positive slope are choice, well, choice 1 has a positive slope with a 3/4. Choice 2 has a negative slope with a 3/4. Choice 3 has a positive slope with a 4/3. And choice 4 has a negative slope with a 4/3. So now you don't have to draw this diagram like I just did. I'm just doing it for expository purposes. What is it that I'm getting to? The point is that if I'm eliminating a choice, I can actually do this not by eliminating all the choices by the two things that are wrong, or the two things that are right simultaneously in my head, but I could analyze the problem for each thing separately. So if I draw now a diagram for RH, okay? So RH, -4, 4, 4, I got that point for R. And I got H at 2, -4. Oops, 2, -4. I just wrote it wrong. It's in the right place, but the wrong number. 2, -4. And I draw that line segment. I have to find a line segment perpendicular to this one. Okay? I have to draw a line segment perpendicular to this one and make sure it goes through the point, what is it, 3, -1. So it has to go through that point. One thing is, if I draw the line perpendicular, if I just estimate approximately where it is, now this is just an estimate, but even just the estimate, the slope is positive. That eliminates any situation where the slope is negative. Choice 2 and choice 4 are eliminated. Even if I don't know how to get the number, choice 2 and choice 4 are eliminated because they have negative slopes. How do I get the number? I have to get the slope of RH. Clearly, I have to get the slope of RH. So the slope of line L is equal to, let's say, y2 minus y. I'm gonna do subscripts a different way. YH minus YR over XH minus XR. And then often you're used to seeing it y2 minus y1 over x2 minus x1 is that equation here. So that equation is not here, so that's another equation that you have to know. So YH is -4 minus YR, 4, over XH is 2 minus XR, -4. And if you go to your calculator and let the calculator calculate this for you, this is -8 over +6. Let the calculator do your arithmetic. How many kids get the bottom wrong? And this does simplify. The calculator will also simplify it for you. Watch. Let's use some parentheses here. Let's learn something. Parentheses. Parentheses. -4 minus 4. Close. Divided by open. 2 minus -4. And I'm going to convert this to a fraction. Math. Arrow frac converts to a fraction. Convert to fraction in simplest form. -4/3. So the slope of a perpendicular line is equal to the negative reciprocal of the original line. So equals the negative of negative 3/4, which is equal to 3/4. Opposite reciprocal, opposite reciprocal. So we have a 3/4 and a positive, and that's this choice. All right, number 19. In right triangle SNO below, it's a right triangle. Yep. So drawn to scale. Altitude NW is drawn. Let's see, I have to, its altitude is perpendicular to hypotenuse SO. Which statement is not always true? Is it SO over SN equals SN over SW? Not always true. Or is it SW over NS equals NS over OW? Or is it SO over ON equals ON over OW? Or is it OW over NW equals NW over SW? So I've taught this in so many ways in other regions, and like I've gotten ways that through various procedures can help you tease out the answer. There's something I call the cheat code, and I will write down the cheat code right now for being able to write your own proportions for the triangle. And the cheat code goes like this, but this is not the way I'm going to do it. I just want to be clear. But the cheat code goes like this. I do the outside. The point is that all three triangles are similar. And then the left side triangle and the right side. And I write three proportions. So the outside triangle, the right angle is at N. On the left side triangle, the right angle is at W. And on the right side triangle, the right angle is also at W. Now, the second angle, S. On the outside triangle, S is at S. On the corresponding left side triangle, well, S corresponds to itself, so S corresponds to itself. And let's say I don't know. I personally at this point do know which angle corresponds to S on the right side triangle, but suppose I don't know, I leave it blank. Now the right side triangle, the outside triangle, O, what does O correspond to on the left side triangle? I don't know because O is not an angle on the left side triangle, but O corresponds to itself on the right side triangle. And so what vertex goes there in that missing gap? The missing gap has to be the missing vertex. On the left side triangle, the only missing vertex is N. And on the right side triangle, again, the only missing vertex is N. So on all three triangles, I have the corresponding vertices in order. N corresponds to W, in that order for outside, left, and right. In that order, S corresponds to S, outside, left, and right, and O corresponds to N, corresponds to O, outside, left, and right. So you can write all proportions that you want for all of the triangles that you want. For example, NS over WS equals S over SN, but this is the thing. That's how I taught it for this problem in other problems. I don't teach it that way anymore for the purposes of a test. It's just too much. I found that it's nicer to have one nice example, and I hate doing it this way, but I'm going to teach it this way. There is a set of integers that if it happens to be that the sides have these lengths, then the triangles are in proportion. And I'm going to use the 3, 4, 5 triangle. So 3, 4, 5 is a right triangle. 6, 8, 10. 9, 12, 15. Then there's 12, 16, and 20. And then there's 16, nope, 15, 20, and 25. And so I happened to notice when I was teaching it to students, and when I was giving up professional development to students and teachers, I was looking for numbers. And I used some harder numbers, but this time I said, what if this length is 9, and this is 12, and this is then 15? Suppose that that's true. After all, this statement, this is something that has to be, these proportions, the proportions are true for all right triangles drawn this way. So it has to be true for this case. So I'm saying, what if this was 9, 12, and 15? Then notice I could also then say, since the short side of the right side triangle is 12, then, and it has to be proportional to the 9, 12, 15 triangle, then this side has to be 16, and this side has to be 20. And this makes the outside triangle the 15, 20, 25 triangle. 9 plus 16 is 25. So what I'm doing, I hate doing a specific, I really hate when I do problems, when people do problems with this method. But this problem, I haven't figured out a way that's wieldy in a very nice way. So what I'm doing is this, I'm coming up with this example. And if anybody has like a super duper fast way for students to learn it in one video in one step, please do send it to me. This is the way I taught it, and it's helped tremendous numbers of students, but it's unwieldy for a one video. Okay, so now what I'm going to do, now that I have this example, 9, 12, 15, 12, 16, 20, 15, 20, 25, I'm going to write down one at a time the proportions and see which ones are correct. So SO over SN, so SO is 25 over SN is 15. Is that equal to SN 15 over SW 9? And if we need not always true. So if this is true, this is not the answer. So, and if you reduce 25 over 15 on the calculator, this is again where, like, if you really struggle with reducing fractions, I would love for you to be able to reduce fractions. Like, for example, divide 25 and 15 by 5. But if you can't do that, 25 over 15, math, convert to fraction, is 5 over 3. And also the 15 over 9, math, convert to a fraction, arrow frac, 5 over 3. So we have 5 over 3 equals 5 over 3. So this is true. And we need not always true. So it's not choice 1. Choice 2, SW over NS. 9 over NS is 15. Is this equal to NS 15 over OW 16? Okay, this is looking bad, because if I reduce this using my calculator, 9 over 15 is 3 over 5. And 15 over 16 is just 15 over 16. That's just false. According to my calculator, 15 over 16 doesn't reduce. And just to be clear, SO, 25 over ON, 20, equals, so I shouldn't cross this out, I should say false. Anyway. So 25, choice 3, SO over ON. SO over ON, 25 over 20 equals ON, 20 over OW, 16. And if you use the calculator to reduce, you get 5 over 4 equals 5 over 4. This is true. We need not always true. So choice 3 is not the answer. And OW, 16 over NW, 12, equals NW, 12 over SW, 9. So, and you use the calculator to reduce, or reduce using your common knowledge, divide by 4, divide by 4. You get 4 over 3, and do the same thing here, divide by 3, divide by 3. You get 4 over 3. And this is true. We needed not always true. So choice 1, 3, and 4 are not the answer. And 3/5 is not equal to 15/16. I hate teaching it that way, again, and I don't teach it that way, but for a one-time video that you're watching right now, for someone like you who's just trying to get the best grade possible, if you memorize this case, 9, 12, 15, 16, and 20, remember I generated this using the 3, 4, 5 triangle proportions. So you can generate the numbers if you don't want to memorize these numbers, and you can get the answer that way. Number 20, a rectangle has a width of 3 and a length of 4. The rectangle is dilated by a scale factor of 1.8. What is the area of its image to the nearest tenth? Great ways to estimate this answer. You're gonna, I think you're gonna love it. Okay, so first I would definitely draw a diagram. Again, basically every test, every region should have a diagram drawn. Okay, so I'm going to draw a diagram. Okay, so I just undid that because I'm going to let I'm going to let the software draw this nicely for me. Thank you. 3 and 4, and I got the area 3 times 4 is equal to 12. So the area is equal to base times height, which is equal to 3 times 4 is equal to 12. Okay, so if I dilate by a scale factor of 1.8, this is bigger dilation, right? Which means that the answer, the area, they want the area is going to be it's going to be greater than 12, which eliminates immediately choice 1 and choice 2. Now we have a passing problem. How do students get this one wrong? Well, they make an assumption that if you multiply 12 by 1.8, that's just the answer. And that's choice 3, and it's wrong. Why is it wrong? Dilations dilate lengths by the given factor. Dilations dilates lengths by the given factor. That doesn't mean that they dilate the area by the given factor. And in fact, it turns out that that's false. Many of us who know biology or have done a little biology know about the square cube law, that as you get bigger, your surface area grows, but much more slowly than your volume. So that the linear square cube law is the more complete statement and is very relevant for math. The lines grow at a certain rate, areas grow faster, and volumes grow even faster than that. So if a length is grown by a factor of 1.8, the area grows by a factor of 1.8 squared. So if you multiply the area by 1.8 squared, you get the answer. But what if you didn't know that? What if you wanted to make an estimate and lengthened the sides by a factor of 2? So you could do just a quick estimate, right? Just a quick estimate. And you could do 6 and 8, and 6 times 8 is equal to 48. So the answer, again, this is 8. The answer is less than 48 by a little. So now my estimate actually eliminates choice 3, and very likely eliminates choice 3. I shouldn't cross it out there because areas factor can grow more slowly than you expect. So choice 4, however, is looking a lot better. Okay. How do we dilate it though? Exactly like we just did the dilation by a factor of 2. So you dilate the side 3 times 1.8 and dilate this side 4 by a factor of 1.8. And so this is equal to, using my calculator, again, use your calculator, 5.4, and this one is 7.2. And if you do 5.4 times 7.2, well, then that's equal to a number, 5.4 times 7.2, and that's equal to 38.88. 38.88, and then we look to the nearest tenth, 38.9. Choice 4. Maybe an unexpected result, but we got it. I love this one because I figured out, like my colleagues and I were just talking about ways of eliminating choices, and I was like, you can eliminate this way, and then someone else was like, you can eliminate it that way. Another person was like, we just kept coming up with ways to eliminate answers over and over and over. So number 21, in the diagram below of circle P, diameter MD that's drawn to scale. That's just a diameter, and it is a diameter, and it is a circle. And chord AL intersect, and so that's drawn to scale. They do intersect at Q, and the measure of angle AQD is 46 degrees. I know that a 45-degree angle is a half a 90-degree angle. That does look like half a 90-degree angle if I draw like a vertical line. It looks maybe like a little bit bigger than 45, which is actually right. So this is drawn to scale. And the measure of arc LD is 124. I know that a 90-degree arc is a quarter circle, and a 180-degree arc is half a circle. So 124 is slightly bigger than a 90-degree arc. So this is drawn to scale. Okay, so this diagram is drawn to scale. And so then the question is, what is the measure of arc AD? Is it 36 degrees, 46 degrees, 51 degrees, or 92 degrees? Using scale, I just confirmed that it's drawn to scale. So using scale, I can confirm AD is less than a quarter circle. So AD is less than 90 degrees by a lot. Okay? Now, I might not be able to make predictions on whether arc AD is smaller or bigger than 46. There is a way that I thought of eliminating every answer except the correct answer in this case. If I draw a diameter here, parallel to PA, so that this angle is 46 degrees, I'm going to call this point A prime. Then the measure of arc A prime D is equal to 46 degrees because it's the measure of the central angle. Therefore, the measure of AD is less than 46 degrees. The measure of arc AD is less than 46 degrees. And look at which answers are left. 36 degrees, the only answer. So if I just drew a diameter parallel to AL, I got a arc that does measure to 46, so AD has to be less than 46. So I did that to confirm that the answer, I got the answer right. Like I did correct math. This is what I was talking about, rigorous math, true math to eliminate answers. I often tell students that there's often many ways of solving a problem, 5 to 10 to 20. It could be that many, 20 or more ways of solving a question, but there's usually thousands, and this is without exaggeration, thousands of ways of eliminating the incorrect choices. That's without exaggerating. And I just use correct math to eliminate all three incorrect choices. But how do I do this question? If I have this arc, ML, then I could get a lot of the math. I know that the measure of ML plus the measure of LD, that forms a semicircle. This is equal to 180. So I have the measure of ML plus this 124 degrees, which I was given that, is equal to 180. If I just do some nice subtraction, let the calculator do that subtraction for you. The measure of ML is equal to 56. Okay. And so I'm going to call this, well, the measure of arc AD, I'm not going to call it X, although you can call it X if you just desperately need a variable. I'm going to call it the measure of AD. There's a theorem that says that the average measure of the arcs is equal to the measure of this angle. So the measure of ML plus the measure of AD divided by 2 is equal to 46 degrees. So now we have an equation. 56 plus the measure of AD, that over 2 is equal to 46. Put this over 1 so I could do my favorite cross multiplication, your favorite cross multiplication. And I get 46 times 2 equals 56 plus the measure of AD. Subtract 56, subtract 56. I let my calculator handle that arithmetic for me. 46 times 2 minus 56, and I get 36. And that's this answer as we expected. As expected. Okay. So let's keep going. We're almost done with the multiple choice with a perfect grade on the multiple choice section. So I'm excited about it. If you're excited about it, please do hit the subscribe button and support this channel. Keep this video playing. You are also supporting yourself by keeping this video playing and getting as much out of it as possible. If you're wondering the best way to use this video, I would highly suggest writing down every single thing that I write down. That's the best thing to do the day before the test. Even if you're watching it at 2x speed, if you're like an hour away from the Regents, believe it or not, if you have to choose between watching me do every single problem and writing down stuff, I would actually write down stuff. Even if you have to miss some of the video. It's better that way. Okay. Number 22, the right prism with a triangular base shown below is cut by a plane perpendicular to its base. Okay, a right prism with a triangular base shown below. It is a right prism with a triangular base, so this is drawn to scale. There's a triangular base right here. Okay. Is cut by a plane perpendicular to its base. So it's gonna be cut. Imagine this is a hunk of cheese or butter, and you're cutting by a plane perpendicular to its base. So you're taking a knife and you're slicing perpendicular to the base. The base is on the table, the cutting board, and you're cutting perpendicular to the cutting board, straight down. So when you cut straight down, a two-dimensional shape of the cross section is always. So what is the two-dimensional cross section? Is when you cut the butter or cut the cheese, and you get a nice edge that you look at. What does that edge? What shape does that edge make? Every single time, according to this, it's always a specific shape. In this case, is it always a triangle? Is it always a rhombus? Or is it always a pentagon? Or is it always a rectangle? If you cut vertically, so I'm going to start cutting there. I'm going to cut straight down. So I'm going to do this carefully. I'm going to draw a straight line. I'm going to put the knife right there. Okay, it didn't draw a straight line for me. I'm going to try it again. Draw a straight line. Ah, okay, it's not doing it. Straight line. Straight line down. I know why it's not drawing a straight line, because I keep starting straight, going upward first. Straight line. And then cut that way. And it made that narrow. I don't know why. But the question is, you might say that this looks like a parallelogram or a rhombus, but the thing is that it's hard to see exactly what happened there. Remember that these are all perpendicular lines, so this is actually a right angle here. If you draw it, if you actually cut it with a horizontal line and cut straight down from there, cut straight down from there, and cut straight sideways from here, notice that you could actually see now in that cut that that is a rectangle. Definitely not a pentagon. A fun fact, you can get a pentagon out of it, not cutting straight perpendicular to the base, not cutting straight down though. You can get a pentagon. Can you get a triangle? You can get a triangle. Can you get a rhombus? I have to think about if you can get a rhombus. But you can get you definitely do get a rectangle if you cut perpendicular to the base. Not a triangle, not a pentagon. Not a rhombus, but again, I don't know if you can get a rhombus. I'm like trying to think about it, but I want to also move on to the next problem. So I'll give you bonus points if you let me know in a video. Is there a way to cut this figure so that you get a rhombus out of it? Number 23, a rectangular fish tank measures 24 inches long, 12 inches wide, and 16 inches high, as modeled in the diagram below. This is definitely drawn to scale. 24 about 1.5 times the 16. The 12 is tiny. This is drawn to scale. If the empty tank weighs 25 pounds and the fish tank is filled with water to a height of 14 inches, then what is the approximate weight of the tank? And they tell us the density of water, 27.7 inches cubed is equal to 1 pound of water. Okay, so since they tell us the weight of the water, notice that I drew immediately like a level of the water. One of the mistakes that students make immediately when they're doing this problem is they ignore the fact that they said that the water is height 14 inches. Another piece that they ignore is the fact that the weight of the tank is given to you. So that's something you're going to have to keep in mind. So and now here is another formula that's not given to you in the formula sheet that you have to know. And I find it interesting that they don't put this formula in the formula sheet. In fact, I actually believe that they just should, because it's not a math formula per se, it's a physics formula, or technically a chemistry formula. Density is equal to mass over the volume. And so they gave us the density. So if we get the mass, we can get the volume. If we get the volume, we can get the mass. They're asking us for the mass. but they're giving us the measurements of the figure. So we can get the measurements of the figure. From the measurements of the figure, we can get the volume according to this formula, a general prism right here. The volume is equal to base times height. That's the general prism volume, which means the volume of the water is equal to the area of the base, which is length times width, times the height, okay? So again, the length is 24, the width is 12, and the height is 16, okay? So let's get these numbers in there. Nope, the height is not 16. I almost got caught there. I almost got caught there because it's the height of the water. You see how easy it is to get caught there? 14. So the length is 24 times the width is 12 times the height is 14. And I let the calculator do this for me. I'm not going to do 24 times 12 times 14. I can. I do 12 times 12, 144 times 2 to get 2, etc. Okay? Or 24 times 12 times 14. And I get 4032. So the volume is 4032. And I know that this is inches cubed. You don't have to give units, but there are times where you want to give units, and there's a problem in this test that if you're not careful with units, you're going to get the question wrong. So now density is equal to mass over volume. They gave the density in cubic inches, so I know that 27.7 inches cubed is equal to over 1 pound is equal to hold on, mass over volume. Sorry, mass over volume. 1 pound divided by 27.7 inches cubed is equal to the mass, which is, I'm going to label M. So let M equal the mass of water. M over the volume, 4032. I gotta do my nice cross multiply. So I'm going to scroll down a little. 27.7 M is equal to 1 times 4032. Divide by 27.7. And I get that the mass is equal to 1 times 4032. 432 divided by 27.7. 145 point, just need that for myself real quick, 0.5595668, which is, they said approximate weight. All of these are rounded to the nearest one. So the approximately equal to 146. And so that's the mass of the water. And then finally, you got to use this tank. The mass total is equal to the mass of the tank plus the mass of the water. So that's 25 plus 146, which is equal to 171. So you see this answer is waiting for people, and it's actually not correct. It's this one, because we got to add the mass of the tank. One more question before we have a perfect multiple choice test. So 24, a circle has a radius of 4.5. What is the measure of the central angle that intercepts an arc whose length is 6.2 to the nearest degree? Is it 35 degrees, 42 degrees, 64 degrees, or 79 degrees? If you have a little bit of knowledge about circles, you might actually be able to get this question right. Let's see if this draws a circle for me. Circle. Yeah, nice. Okay, so now if the radius is 4.5, so I'm going to draw a radius of 4.5. Now I have to have a central angle that intercepts an arc of 6.2, length 6.2, okay? And I'm going to label this angle X. And I have to know what that X is. Now you could use my diagram to make an assumption, but here's the problem with using scales on this diagram. I drew it. The problem didn't come with this diagram. So I used knowledge that I have about radii and arcs. In Algebra 2, you would learn that 1 radian is equal to 1 arc angle of length 1 radius. So if you stop going around at around 4.5 here, 4.5, you get a radian, that angle. And I happen to know that 1 radian is approximately equal to 57 degrees. That's prior knowledge. Therefore, the answer is greater than 57 degrees. Now, suppose that you didn't know that. Is there something that you could do to eliminate some answers? There is something that you could do to eliminate some answers. If you have a circle, because my goal is to get you the best grade possible, so eliminating some answers is going to be a great thing. You have a circle. If you have a radius of 4.5, now if you just illegally kind of draw an isosceles triangle, okay, didn't draw it straight there. Isosceles triangle, okay, let's just assume that that's isosceles, it's close enough. If that's 4.5 and that's 4.5, that makes that 60 degrees. And this arc is slightly bigger than 4.5. And it also measures 60 degrees. So my estimate, since 6.2 is a lot greater than 4.5 in proportion, we're talking about an arc that might measure like 5-ish, maybe less. 4.5 versus like 5-ish compared to 6.2. Right? So since 6.2 is a lot bigger than 4.5 in proportion, I'm going to assume that the answer is greater than 60 degrees. And that does eliminate 42 and 35 for sure. Now, 64 versus 79, I'm kind of stuck there if I don't know how to do it. But how do I do this problem using a formula? There is a formula that you can memorize. S equals R, S is equal to R central angle theta times 2 pi over 360. But I don't like that formula because it's hard to memorize. Because it's like, where does the R, where does the S go? Where does the 2 pi, where does the 360 go? And students are like, wait, this is a lot of things to keep track of. I get stuck. I'm going to instead use proportional reasoning. Proportional reasoning is actually a skill that helps you across all of math. And it's not that hard to use, especially if you have a part over whole equation. Okay? Part over whole. Proportionality equation. Funny fact, I've never heard this equation being called a part over whole proportionality equation. And I was watching a math video of a person doing a math Regents, and they suddenly say part over whole proportionality equation in my exact words. And I'm like, you've been watching my videos. Even people who do math videos watch my videos, which, listen, let them keep doing it if it helps them. But the part over the whole proportionality equation says, I'm going to do the part of the circle over the whole circle in central angles. So I'm going to use X is the part of the central angle over the whole central angle, the whole circle angle is 360. And that's equal to the part of the circle, the arc length, is 6.2 over the whole circle length, which is 2 pi r, right? Pi r. Might as well put the numbers in. 2 pi. This is the circumference, right? Is 2 pi times 4.5. And notice that this equation only has one unknown, x. So we could solve it using, this cross multiplication is becoming popular. X times 2 pi times 4.5 is equal to 6.2 times 360. If you wanted to put those numbers into the calculator now, you can. It might even help you. Or you could do it later. I'm going to do it later. Divide by 2 pi times 4.5, because I obsessively use parentheses in all the correct places. 2 pi times 4.5. Sometimes I even use extras as long as they're legal. X equals, now let's get our calculator out. Let's put these numbers in. Come on, there we go. 6, parentheses, you don't need the, okay. 6.2 times 360 divided by parentheses 2 pi times 4.5. Oops, I missed the parentheses. Parentheses 2 pi times 4.5. And I get 78.94. Okay. 78.94085,177. I do recommend actually writing the whole thing and then circling their rounding goal and then you rounding again. So x is approximately equal to 79 degrees. And we see 79 degrees as the answer right there. We've got a perfect multiple choice section. That is a much more than a passing grade. Almost every single question got down to a passing problem, meaning that we have eliminated almost for every question at least 2 choices. Many questions we've eliminated 3 choices, meaning we got the question 100% right without necessarily knowing how to do the problem. And at least maybe some of the questions we've eliminated 1 choice, which may not seem like a big deal, but we still get a better chance of getting it right once we guess from that point. And in fact, because so many of the problems were passing problems after we were done, and the fact that you could do more methods to eliminate more incorrect choices, we've officially, just even if we didn't do the correct math at any point, with wild guessing and using proportional reasoning and using drawn to scale, and we were able to get to the point where we can pass the test even just with that. Now we go to the part 2s, and the methods that we used in part 1, again, we're going to use them in part 2, but notice since there's no multiple choice, there's no guessing. So we have to do the math. However, the great thing is that if you just do what you would normally do for a part 1 question, in the part 2, the math that you would do in a part 1 question for the part 2s, you can get the points. Similarly, if you learn how to do a part 2 question, then that's a guaranteed point for part 2 and for part 1, because a very similar problem is likely to appear in part 1, which means that every time you learn with 100% certainty how to do a part 2, 3, or 4 question, that's worth 4 points, not 2. It's worth 4 points, not 2, because you know how to do a part 2, 3, or 4 question, and you know how to do a part 1 question. Okay, not necessarily drawn to scale, almost definitely. And a big lesson here, each correct answer will receive 2 credits, but here's this last sentence, the second to last sentence. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. 1 credit is half a multiple choice question. If you just give the answer, like let's say you don't know how to write down any of the work, but you know how to do some calculator stuff and you just write down an answer and it's correct, you get a point. So never leave these blank, even if you have to do some calculator work to estimate your answer, because if your estimated answer is correct, boom, you're done. Like this one. Number 25, in the diagram below, triangle SUV is similar to triangle TRE with the vertices in that order. So you know which vertices correspond to each other. If SU is 5, UV is 7, TR is 14, and TE is 21, determine and state the length of SV. I'm going to write X like you guys like, okay? But I want to point out the ordering of the vertices really super duper matters. So SUV is similar to TRE. S, U, V. S next to T, U next to R, V next to E. Okay? Why does that matter? Because you have to know which vertices correspond to which vertices in each triangle. So which sides correspond to which sides in the triangle. So now I see that this length is 5, SU is 5, and TR is 14. I need to get SV given that TE is 21. Now let me look at scale. 5 versus 7. 7 looks a little bit bigger than 5, but not double. So this is drawn to scale. And also the 21 looks about to be 1.5 of the 14, so this is also drawn to scale. And they also look similar. They look like the same triangle, just one of them bigger than the other, so this is drawn to scale. Drawn to scale. So this triangle is definitely drawn to scale. I could use scale to just estimate my answer. Like if I said, for example, oh, I see 21 is 1.5 times 14. So if I assume that X is 1.5 times 5 and I just write 7.5, maybe I get lucky. I get a point that way. But let's see. This is the one problem where I would say the bottom side is technically, the 7 is technically not necessary. However, there are methods of doing this problem where if you use the bottom side, you can get you can get your points, okay? So it's not that it's totally irrelevant, but it isn't necessary. If I do the corresponding sides in proportion, I get that SU over TR is equal to SV over TE. And now I put the numbers in. If I write 5 over 14 equals SV x over TE, 21, even if I don't know how to solve this equation, if I happen to know how to solve the equation on the calculator, and I just write x equals what it is, 7.5. If I write what x is, what it is, I get full credit. Because this is not an algebra test. They don't expect you to show infinite steps in the process of solving the equation. However, I am going to show my steps. I got 14x equals 5 times 21. If I divide by 14, I do not have to do this arithmetic on paper. I go to my calculator and I type in 5 times 21 divided by 14, and I get 7.5. Which, had I guessed that, I would have gotten a point. But now with the work, I get 2 points. Number 26, this is a recommendation that I have for teachers. I no longer teach constructions on paper, because like what does the compass do? All those weird dashes that are in constructions they can be weird for students. And when you look at them on textbooks, they don't always actually construct the arcs properly. Like they sometimes draw like an arc that like simulates the construction mark, but isn't the construction mark, and it messes with students' minds. If you're a textbook writer listening to this video, stop doing that. Like make your arcs that are circle arcs actually be the correct circle arcs. But this is the lesson. When I teach constructions, I no longer have students draw just little arcs or little parts of the arc. I have them draw the entire circle, because all that a compass is a circle drawing tool, and all that a straight edge is a line segment or line drawing tool. So if you release yourself from the idea that a compass is the constructor and a straight edge is a constructor, and you just use this compass as the circle drawer and the straight edge as the line segment drawer, then you get the answer, which then also allows you to go to technology and do the problem with technology. Okay, so what is this problem? Let's actually go ahead and read the problem. We didn't read the problem yet, so let's actually read the problem. It says, using a compass and straight edge, construct a line of reflection that maps triangle ABC onto its image DEF. Leave all construction marks. So we need to find this middle line that is the line of reflection. They told us, though, that ABC maps onto DEF. So ABC in that order, A maps to D, B maps to E, F maps to C. There's going to be a line somewhere in the middle here somewhere, but that's not a construction. It's going to be somewhere in the middle there. How do we construct it? The thing to know about the line of reflection, every single point on the line of reflection is equidistant from the corresponding points on these diagrams. Okay? So if I find 2 points that are equidistant from C and F, then I found a line of reflection. So just for exposition, if this is CF, okay, that's CF, it is CF, right? If I find 2 points that are equidistant from C and F, then I found the line of reflection by drawing a line through those 2 equidistant points, those 2 points which are equidistant from C and F. So why did I draw this orange line for exposition? Because if I draw a circle with radius CF centered at C, every single point on this green circle has the same distance from C as F is from C, because that's literally the definition of a circle. Every single point on the circle is equidistant from the center. So F and every single point on this green circle are the same distance from C. So the equidistant points are going to be somewhere up here. I can't just guess where it is, though, and somewhere down here, but I can't guess. But if I draw another circle with radius CF, but now centered at F, now I have these 2 points. And I'm gonna change the color of this circle to like purple. Nope, to red. Now, this point, which for exposition, I'm gonna label it G. Point G, being on the green circle, is the same distance from F as G is. So, and G being on the red circle is the same distance from C as F from F as C is. So GC and GF are equal to each other. A better argument, I think, just to make it a little bit clearer, a better argument is that CG being a radius of the green circle and FG being a radius of the red circle have to be congruent. Same thing is true about this point on bottom. CH being a radius of the green circle is congruent to CF, and FH being a radius of circle F is congruent to FC. So H is also equidistant from C and F, making this the line of reflection, or more appropriately with a line, making this the line of reflection. Now, I'm going to do this construction without as much exposition because I think it's important for you to see that. Okay, so, but I am going to draw this radius from C to F because I'm going to make that the radius of 2 different circles, a circle centered at F and a circle centered at C with the same radius CF. Therefore, these 2 points on these 2 circles are equidistant from C and F. This point and also this other point is equidistant from C and F. So the line going through those 2 points is now the line of reflection. And I've constructed the line of reflection. If you draw this with your compass, the circles with your compass and the straight lines with your straight edge, you get full credit. And that's how to do this construction. And there's a lot of ways to do the construction. I'm tempted to do 1,000 other ones, but for the sake of completion, that's number 26. For the sake of completion, instead of other things, uber completion, I guess. Number 27, triangle MAX has vertices with coordinates m, -5, -2, a, 1, 4, and x, 4, 1. Determine and state the area of triangle MAX. The use of the set of axes is optional. The only method that I know of not drawing it is called the shoelace method. If you know the shoelace method, great. If not, I literally heard of it. It's crazy that I heard of it like 5 days ago, and then it came up in my life twice since then. So now I'm mentioning it to you. However, I'm not going to use the shoelace method. I'm actually going to draw this triangle. 1, 2, 3, 4, -5, and -2. Okay. Okay. 1, 2, 3, 4, -5, and -2. 1, 4, 1, 2, 1, 2, 3, 4, and 4, 1. 1, 2, 3, 4, and 1. Okay. So now I draw the triangle. Okay. Try that one again. Try that one again. Come on. There you go. And was that too archy to? There we go. Okay. So these are the vertices M, A, and X. And it turns out that this triangle allows for so many different ways of calculating the area. Not everyone allows so many different ways of doing the area. So I'm gonna do one way that works every time, but like you could break up this triangle in multiple different ways, for example, to get the area. Like you could draw a horizontal line, you could draw a vertical line, you could recognize that just by coincidence it happens to be a right triangle. So many different ways of doing this problem, but I'm going to do it one way that it happens to be extremely useful in a lot of scenarios. So I'm going to draw a rectangle, the smallest rectangle that I can, around this triangle. And if it draws straight lines for me, great. But it looks like, oh, it looks like there. Okay. Can I, after the fact, can I click on it and make it straight? Nope. No. Okay, that's good. So I have that rectangle. So what's the benefit of this rectangle? I know I'm going to call the area of the triangle K. And I'm going to call this area of this triangle over here that I've made B. And I'm going to call this triangle area C. I'm going to call this triangle area D. Okay? I know that the area of the rectangle is equal to the area of the individual parts of the rectangle, so K plus B plus C plus D. And why is that beneficial? The area K might be difficult to get, but the rectangle's just a nice horizontal vertical rectangle. I can get that area. And the other three triangles also have a horizontal and vertical base and height. So I can get those areas. So the area of the rectangle is equal to base times height. And that's equal to the base is 1, 2, 3, 4, 5 plus 9. 4 is 9 times height is 6 is equal to 54. K is an unknown, but B has area 1/2 base times height, which is the area of a triangle. So 1/2 the base. I could take the horizontal side to be the base. 6 times the height is 6. This height is 6, and I get from my calculator I get 18. C is has area 1/2 base. The base is 3 and the height is 3. 3 times 3, which is equal to my calculator 4.5, and D is equal to 1/2 its base, which is 9, times the height, which is 3, which is equal to 13.5, according to the calculator. 27 divided by 2 is 13.5. So if I plug those into the equation, area of rectangle equals K plus B plus C plus D, I get that 54 is equal to K, which is unknown, plus B, which is 18, plus C, which is 4.5, plus D, which is 13.5. I ran out of space there. Let me erase that. Plus 13.5. 5. There we go. Okay. And so 54 is equal to K plus 36. Subtract 36. Subtract 36. And I get that K is equal to 18. And there we go. That's my answer. So I have to say that the area of triangle MAX X is equal to 18. Okay? But again, this allows for so many ways. Draw a horizontal line, get the area of the top triangle, the bottom triangle, or draw a vertical line, get the area of the left side triangle, the right side triangle. So many different ways. Okay. Number 28. A person observes a kite at an angle of elevation of 32 degrees from the line of sight that begins 4 feet above the ground, as modeled in the diagram below. At the moment of observation, the kite is 70 feet above the ground. Okay. Determine and state the horizontal distance x between the person and the point on the ground directly below the kite to the nearest foot. Okay. So they want this distance x, which happens to be the same as this distance x. Now, this is one of those diagrams where I said technically not drawn to scale, because a 4-foot person versus a 70-foot high, like if you draw on the paper 4 feet, then 70 feet ends up being maybe the size of the page, but they only drew it like that big. So technically that's not drawn to scale. But in this case, the scale doesn't even matter, because 70 minus 4 is equal to 66. And now the triangle, we're only dealing with the triangle, right? So now this side is length 66, this side is length x, and this angle is 32 degrees. That does look like a 32-degree angle, because I know what a 30-degree angle looks like. I'm so used to seeing those triangles. And that angle is ever so slightly bigger than 30 degrees. Drawn to scale. So even though the person is not drawn to scale relative to the 70, the triangle itself is what matters. The scale of the triangle matters. So what that means is, so we're trying to determine the horizontal distance x. If you go nuts and you decide to make an estimate, you're like, what if the angle was exactly 30 degrees? I know the x radical 3, 2x formula, and if I do 66 radical 3 to make an estimate, and that'll give me a nice way to check my answer, right? So there we go. So my estimate, which I'm a big fan of making, is 66 radical 3, assuming a 30-degree angle. So 66 radical 3, 66 radical 3, and you get 114, all right? 114. And then if you say, oh, but the angle's 32 degrees, so if you have this angle and you actually shrink, if you have to increase the angle, you have to, without changing the length of the height, you have to shrink the length of the base. So it's actually slightly smaller. But ever so slightly smaller, because a 32-degree angle versus a 30-degree angle, we're talking about proportionally ever so slightly smaller. So maybe smaller by somewhere between 5 and 10. So somewhere between 104 and 109. And if you literally just make a guess, remember, every single answer, if you just write down the answer without doing any work, if you just write down a guess somewhere between 104 and 109, you actually have 1, 4, 5, 6, 7, 8, 9, 1 in 6 chance of guessing correctly, 1 in 6 chance of getting a point for free, because the answer is between 104 and 109. It's like that. So I'm not opposed to that, but that's like if you're like really trying to eke out some points. But how do we do this? Yet another appearance of SOHCAHTOA. So this is the leg adjacent to the 32-degree angle. Okay. And on the 66 is this is the hypotenuse, right? And the 66 is the leg opposite to the 32-degree angle. So if I use tangent, again, SOHCAHTOA, SO over H, SOHCAHTOA. So opposite and adjacent, tan 32 degrees is equal to the opposite leg 66 over the adjacent leg x. I put this over 1 so that I have something to cross multiply with. And I got 66 times 1 is equal to x tan 32. Divide by tan 32. Divide by tan 32. And I don't have to get the answer on paper. I could literally go to the calculator, and this one I actually just have to go to the calculator. It's physically impossible for you to be able to write down tan 32 with any amount of accuracy. 66 times 1. I know that 66 times 1 is 66, but for the purposes of exposition, this is how you do it and get your points. I did it times 1 divided by tan 32. And we get this answer. Didn't I say between 104 and 109? So this is what I do to get full credit. I actually write the full decimal. X is approximately equal to 105.6220789. And then I say X approximately equal to what they said to round to the nearest foot, 106. The 6 causes me, with 5 or above, it causes me to round the previous number of the 5 to up to 6. Notice I didn't give the units because they gave the units. If they gave the units, you don't have to give the units. And here's the thing, I haven't seen a problem where they didn't give the units, ever. And so not giving the units actually helps. However, there is a problem on this test where if you're not careful with your units, you'll get it wrong because they give some things in inches and some things in feet. Number 29, in triangle AGL below, N and E are the midpoints of AG and AL respectively. NE is drawn if NE is 15 and GL is 3x minus 12, determine and state the value of x. Okay, so I'm going to label some stuff. So the midpoints of AG and AL. So N is the midpoint, N and E are the midpoints of AG and AL respectively. So this is congruent to this. This is drawn to scale. And AE is congruent to EL. This is also drawn to scale. NE is 15. And GL is 3x minus 12. Minus 12. Determine and state the value of x. Here's a great piece of advice. If you use geometry to make an assumption, suppose you don't know what the true correct equation is, but you don't guess at the equation. You use geometry to make an assumption about what the equation might be. Like, for example, I mean, visually speaking, I feel like they're trying to tell me that GL is twice NE. Suppose I didn't know that, then but I just assumed it, and I just write 30 equals 3x minus 12. Turns out that that's the correct equation. Solve for x, you get 2 points. Turns out that's how to do it. So how to do it? Um, this one, because this is the correct number of dashes. I apologize for that. So this is, if I write a proportion, AN over AG is equal to 1 over 2, and that's equal to AE over AL, and that's also equal to NE over GL. So equals 15 over 30 over GL. So 1 over 2 equals 15 over GL. And if I cross multiply, I got 30 equals to 1 times GL. And if you want to divide by 1, you find out that 30 over 1 is 30 is equal to GL. Okay? So now I know that 30 is in fact GL. So if I write 30 equals 3x minus 12, add 12, add 12, I got 3x equals 42. Divide by 3, divide by 3. I got x equals 14. And that's full credit. And we're about to complete 30 questions of a perfect test. In the diagram below, triangle TAN is the image of triangle SUN. That's clever. You get a TAN when you go out in the sun. Okay. In the diagram below, triangle TAN is the image of triangle SUN after a reflection over NZ. Let's see. We're at T, A, and just to make sure the vertices are in order, S and U. Okay, so the corresponding vertices do match, and these do look congruent, so this is drawn to scale. Use properties of rigid motions to explain why triangle TAN is congruent to triangle SUN. So we talked about problems like this, and this is a fact that you have to know, that rigid motions preserve lengths, angles, and areas. So triangle TAN and SUN are the same size and shape. And that's actually all you have to say. So rigid motions preserve lengths, angles, and areas. So triangle TAN and triangle SUN are the same size and shape. For students who struggle with this problem, if you leave that question blank, then you lose. Because I would say you don't know nothing. There's not a double negative. You don't know nothing in this problem. You know something in this problem. If you just say that's something, that's probably enough for a point. And it might be enough for 2, because we're not expecting super duper grammar. We just want you to know why they're the same size and shape. And so you just might say something that gets you the points. And that's all you need, right? So number 31, a pyramid with a square base is made of solid glass. The pyramid has a base with a side length of 5.7 centimeters and a height of 7 centimeters. The density of the glass is 2.4 grams per cubic centimeters. Determine and state to the nearest gram the mass of the pyramid. As they get better at writing tests, they stop like repeating the same almost nearly the same exact question. But if you notice, earlier in the test in a multiple choice, like there was one with like a cone with a dense. There was one with a, what was it? It was some sort of shape with a density. And now they have another one with a different shape and a density. Where is the one with the shape and the density? It wasn't the volume one. It was it was the water in the tank. So it was like a rectangular prism and a density, right? This one is a pyramid and a density. So now we do have to look they give us the density in grams per cubic centimeter, and they give us the length and width and height in centimeters also. So we do have to make sure that they give us in the right units. So there's a square base. Oops. Square base. From the center we go up. That's there, 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 and there. Okay. I'm gonna erase this line segment. Oops. Wow, that was a lot of erasing. Trying to erase. Nope, it's not going to let me draw that, erase that line segment. Let me see if it let me select that line segment. Okay. So we have, the pyramid has a base with a side length of 5.7 centimeters, 5.7, 5.7, and a height of 7. So I'm going to draw the height in a different color just so we can see it a little bit better. 7. Okay. And now we have to go into the formula sheet and find out the formula for the volume of a pyramid. And here it is, 1/3 base times height. This is true for a general pyramid. This is true for, like, the pyramid could have a triangular base, a square base, a pentagonal base, a hexagonal base, or even a circular base, making it a cone. Okay, so you just have to know what kind of shape the base is, so you have to be able to get its area. So the volume is equal to 1/3. I'm going to call this L and L and H. L times L times H. So this L times L is the base, the area of the base. So this is equal to, oh, and by the way, the other thing I didn't establish, the formula that you need again, it's clear now that you need the formula no matter what, right? Density is equal to mass over volume. So you really do need that formula. Density equals mass over volume, and it's not on the formula sheet. I do think, morally speaking, it should be on the formula sheet. And I think that the Regents makers, like, they should change their policy and actually add that to the formula sheet now rather than later. They don't have to wait for the standards to change before they add that formula. I think it's because it's not a math formula truly, it's a chemistry formula, right? Anyway, or yeah, a chemistry formula. So to get the mass, we have to use the volume. So first we have to get the volume. So the volume is equal to 1/3 times 5.7 times 5.7 times 7. And I'm going to use the calculator to get this number. So 1/3 times 5.7 times 5.7 times 7. And this is again 75.81, and that's an exact answer. So V equals 75.81. Now I'm going to plug into the density equals mass over volume formula. The density equals mass over volume. So we have the density is 2.4. 2.4 is equal to mass over 75.81. Put this 2.4 over 1, so we have some nice cross multiplying that we could do. So we have m times 1 is equal to 2.4 times 75.81. And on the calculator, we get m is equal to approximately 181.994. That's from the calculator, and then they set to the nearest gram. So m is approximately, the 9 causes us to round up. Okay. And we get 182 grams. 182 grams. Okay. Section 3. Another part for all this, a correct numerical answer with no work shown will receive only 1 credit. So if you just give the answer, great points. Diagrams are not necessarily drawn to scale, almost definitely. Something about the part 3s and part 4s. A lot of students take that whole philosophy of I should focus only on the part 1s when it gets negated by someone like me and say, well, okay, I'll focus on the part 1s and 2s, but the part 3s are harder than the part 2s and the part 4s are harder than the part 3s. so I'm not going to focus on the part threes and fours, and it turns out that that's actually just false. It's false thinking. The part threes are not necessarily harder than the part twos. They're just longer than the part twos, but they're also double the value. And the part fours are not necessarily harder than the part threes. They're just, or the part twos. They're just triple the values of the part twos, and 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 two more than the part threes, and also two and four more, triple the value of a part one. So yes, they're technically harder in total, but each part is not. Okay. So number 32, a drone is used to measure the size of a brush fire on the ground. And believe it or not, this is a similar way to how drones measure brush fires. Like a drone could be flying around in wind, everything could be shaking the drone. And if the drone can see the forest fire, even if it's shaking, it can measure the size of the forest fire. Just literally. This is similar to how it's done. Similar to how it's done. There's actually a different degree of freedom that the drone takes. And if it's a high level drone, the drone can actually take the measurement in multiple ways and do some error checking. But usually, instead of checking the distance, they check the vertical distance once. They check the vertical distance, they check the angles, done. But in this case, this drone is measuring in a different way. So what? Okay, so a drone is used to measure the size of a brush fire on the ground. Segment AB represents the width of the fire, as shown, and I'm going to do a little ready there, a red there, so it's like, oh, it's a fire. As shown below, shout out to the people in California. The Palisades fire, that's a whole thing. That happens to be going on right now. So, and I definitely want to send a shout out to all the firemen and who are working to put out that fire, police officers who are protecting the people, and anyone who is making the right kinds of donations, and anyone who is housing anybody who is affected by the Palisades fire. I want to give a shout out to you too. This is a fire that is not just hurting uh, regular people like me and you. I mean, celebrities technically they are regular people too. But the thing is, many of them can afford to just move on and buy another house. Of course, memories are lost, or items of value are lost. But yes, a lot of people have the ability to just buy a new house, and there's a lot of people who just don't. So I just want to give a shout out to the people who are also looking out for those who are really struggling at this time. Um, so a drone is used to measure the size of a brush fire on the ground. Here's my fire drawn in red. Segment AB represents the width of the fire, as shown below. Great. The drone calculates the distance to point B to be 1,076 feet and an angle of depression of 25 degrees. At the same point, the drone calculates the distance to point A to be 774 feet and at an angle of depression of 36 degrees. Determine and state the width of the fire AB to the nearest foot. If you don't know how to do this problem, remember this is a 4-point question, and you do part of it correctly, you do get points. And I could even show you this big fat sheet that I think at the top says for teachers only. So it says for teachers only, though, by the way, I just want to be clear. You're very free to look at it. This is not cheating. But the reason it says for teachers only, it's for teachers only during the grading period. Afterwards, you can look at it all you want. Like if you do one correct trigonometric equation, but nothing else is written, or if you do correct work to find something, you get 2 points. That's a multiple choice question. That's a full multiple choice question. So if you get your 2 points, that's a full multiple choice question. If you just write a correct equation, then you get a point. So there are friendly ways of getting so many points, and not every single possible way of getting points in this test is in that sheet. So what is it that I do? I know that parallel lines form that zigzaggy corresponding alternate interior angles being congruent, which means that this angle here is 36 degrees, And it means also that this angle here is 25 degrees. And now I actually have some trig that I could do. So I can't get AB in one step. I cannot get AB in one step. And for students who are looking to get AB in one step, just remember this is a part 3 question. Just by being a part 3 question, chances are you should actually purposely be looking for literally anything except AB. Anything except AB, because it's probably a multi-step problem. So if you're trying to say, wait, how do I get AB? No, focus on how do I get anything else. And in fact, I know that AB is somehow related to, I'm going to call this point P for completeness. I know that AB is somehow related to PA and PB. In fact, if I get PA and PB, I can just subtract and get AB, and that's how to do the problem. So PA, so this is a right triangle. So this is the leg adjacent to the 36-degree angle, and this is the hypotenuse, okay, for the 36-degree angle triangle. So SOHCAHTOA, so the adjacent and the hypotenuse, that's the cosine. Cosine of 36 degrees is equal to the leg adjacent, PA, which is a mystery, over the hypotenuse, which is 774. I'm going to cross multiply, put a 1 under there so I can cross multiply. And I get that PA is equal to 774 cosine of 36. I'm going to show you a little trick right now. You don't have to simplify that number right now. And in fact, it's going to be a decimal, but you don't have to do that right now. Get that, worry about it later. PB, I'm going to do PB also. PB in the same exact way. This is the leg adjacent to the 25-degree angle. So I have, and then I have the hypotenuse for the 25-degree angle triangle. So again, SOHCAHTOA. SOHCAHTOA. Again, adjacent and hypotenuse, that's cosine. So cos 25 degrees is equal to adjacent PB over the hypotenuse, 1076. And some of you might be wondering, why am I doing this? But let's actually just keep going, because this is a part 3 question, probably a multi-part question. PB is equal to 1076 cos of 25. And so why did I do this? What I said before actually is the reason. I see that PA plus AB, which is AB is the thing I'm looking for, is equal to PB. And now I have two values. I have two of those values. PA is 774 cosine 36 plus this mystery AB is equal to PB, which is 1076 cosine of 25. And if I just subtract 774 cosine of 36, subtract 774 cosine of 36, I get that AB is equal to 1076 cosine of 25 minus 774 cosine of 36. And now I go to my calculator. Okay. So the reason I didn't plug it into the calculator earlier is because I'm going to have to plug it into the calculator now. 1076 cosine of 25 minus 774 cosine of 36, enter, is 349. And this is what I train my students to do again. So I'm I train them to write the entire insane decimal. So AB is equal to 349.00800252. And so AB is approximately equal to, now I go to see what they told me to round to the nearest foot, 340. So this 9 tells me to keep that 9. The 0 tells me to keep the 9 the same. So 349. 4 points. And if I got any part of this, 2 points. Big deal. Number 33. This is a great example of a problem where letting the calculator do your arithmetic is just a really smart idea. It says that quadrilateral ABCD has vertices with coordinates A, -3, 6, B, 6, 3, C, 6, -2, and D, -6, -2. -6, 2, rather. I got scared for a second because I've done this problem before and it didn't match what I had. So quadrilateral ABCD has those vertices. So I'm going to draw these these line segments. Okay. Notice that I'm drawing these with a straight edge. Okay. Why is it not letting me draw these? Okay. Why is it not letting me do this? Okay. I don't know why it's not letting me draw that one straight, but okay. I don't know why it's not letting me draw this one straight. It's kind of annoying me, but especially the vertical one, which it actually usually just does. There we go. Okay. So this is my, and I want to point out here, it says that use of the axes is optional. If you're not using the axes, like, what are you doing? Come on, just use them. A, -3, 6. B, 6, 3. C, 6, -2. And D, -6, -2. Okay? So it says that Joe defines an isosceles trapezoid as a trapezoid with congruent diagonals. So I have to draw the diagonals. Well, use Joe's definition to prove that ABCD is an isosceles trapezoid. So I'm gonna draw these diagonals. No, I don't. Okay. I'm going to draw these diagonals. I have to prove that this is a trapezoid with so it says use Joe's definition to prove that ABCD is an isosceles trapezoid. Now, if you prove that ABCD is an isosceles trapezoid in any other way, you might get some points, but you have to do it his way, Joe's way. So let's actually prove it Joe's way. First, you have to prove that it's a trapezoid with congruent diagonals. So to prove that it's a trapezoid, so you have to do both of those things. Prove that it's a trapezoid, and then you have to prove congruent diagonals. So prove that it's a trapezoid has to have one pair of parallel sides. This and this are parallel. How am I going to prove that? The slope of AB is equal to YB minus YA over XB minus XA, and that's equal to, let's see, 3 minus 6 over 6 minus -3. And I'm going to show you how to do this on the calculator to write proper fractions. One way to do it is to obsessively use parentheses in all the correct places, just obsessively. But there is a way to put proper fractions, or not proper fractions, like WYSIWYG fractions, like with the horizontal fraction bar in the calculator. So if you go to math and go to number, the very last option under number is n over d, and look at that horizontal fraction bar, 3 minus 6, and the denominator 6 minus -3. And this is going to give me the reduced version of this fraction, -1/3. Okay, and now I have to do the slope of CD. The slope of CD is equal to YD minus yc over xd minus xc. Notice that I had to write down, for full credit, I have to write down the arithmetic that I have to do and then let the calculator do the arithmetic for me. But that minimum has to get done. You have to write down the arithmetic that you're going to do. So in this case, yd is 2, yc is -2, over xd is -6, minus xc is 6. And I'm going to do the same thing as I just did for a second set of practice. Math, go to number. The last option is a Weiserick fraction, a horizontal fraction bar. 2 minus parentheses -2 divided by -6 minus 6. Enter. You get -1/3. And then you could say the slope of AB is equal to the slope of CD. So ABCD is a so actually you have to say AB is parallel to CD and ABCD is a trapezoid. So I proved that it's a trapezoid because it has one pair of parallel sides. Now the next part, I have to prove that the diagonals are congruent, which means they're the same length. So let's do that. Prove that AC equals BD. I'm going to use the distance formula. So the length, the distance between AC, or the length of AC, I'm just going to say AC, equals radical, parentheses, YC minus YA squared plus XC minus XA squared. And I'm going to plug in the numbers and then let the calculator simplify the radicand. So radical, I do have to scroll up, okay? But now my screen is a little bit too big. Even in long form, my screen is too big. So I'm going to look at my paper. YC is -2 minus YA is 6 squared plus parentheses XC 6 minus X A is -3 squared. And now at this point, let's just confirm, yep, everything's right. At this point, I just need to write down the numbers in the radicand. -2 minus 6 squared. I don't have to simplify on paper. Plus 6 minus a -3 squared equals 145. So this is equal to radical 145. And similarly, BD equals radical parentheses YD minus YB squared plus XD minus XB squared. And I plug in the numbers and then let the calculator handle the arithmetic for me. So parentheses, I'm going to use my paper again because the numbers are a little bit too high up on the screen. So 2 minus 3 squared plus parentheses -6 minus 6 squared equals, and I'm going to let the calculator calculate the radicand for me as before. Parentheses 2 minus 3 close parentheses squared plus parentheses -6 minus 6 close parentheses squared. Enter radical 145. So radical 145. So what does that show? So AC equals BD. So the conclusion is that AC is congruent to BD. And the conclusion is, according to Joe, ABCD is an isosceles trapezoid. And that was a 4-point problem. But again, like if you can get any part of it, like if you prove that the A, B, and CD are parallel, 2 points. If you didn't know how to do that, but you know how to show that A, C, and B, D are congruent, 2 points. 2 points is a multiple choice question. If you did know how to do that, but you made a simple mistake in either one of them, you could still get a point. 2 points, 2 problems, and 10 points. Listen to this: 2 problems and 10 points away from a perfect grade. So are the part 3s and part 4s worth doing? Let's see. An 80 is a perfect grade. If I don't do the last problem in part 3 and the last part 4 problem, 70 points. I'm down to a 90. Are the part 3s and part 4s worth focusing on? That's a good, just what I just said is a good enough argument to say yes. But yet another reason, another great argument why these are worthwhile to focus on. Again, there's so much partial credit like this. They're sprinkling partial credit all over the place for you. Number 34, Ali made 6 solid spherical decorations out of modeling clay. Each decoration has a radius of 2.5 inches. The weight of clay is 68 pounds per cubic foot. Units. Determined and state to the nearest pound the total weight of the 6 decorations. Now, I just noticed they said inches and feet. Yet another conversion that is not, shockingly, not given on this paper. Technically, there's enough information to convert from inches to feet. Culturally, I think that they should have given us the fact that 12 inches is equal to 1 foot in the formula sheet. I think that's just a cultural thing because there are plenty of countries that don't bother using inches and feet and use like meters and centimeters and use the decimal system. But technically, can you convert from inches to feet? You can convert from inches to centimeters, centimeters to meters, or inches to meters, meters to kilometers, kilometers to miles, miles to feet. Ugh. And you get 12 inches in a foot. Or you just culturally know that 12 inches is equal to 1 foot. Okay? Not on the sheet. Definitely know it. Okay? So this is yet another problem also, by the way. The third time in this test, density is equal to mass over volume. Do you have to know that then? Yeah. And it's not that you can't get most of your credit, but every single time you don't know density equals mass over volume, if you think of that as minus 2 points, then 3 times I think we use that formula. So that's minus 6 points. Vice versa, if you know the formula density equals mass over volume, that's plus 6 points. So if you just get, and this problem can feel a little tough, but if you just go through the process, then you can get full credit. And if you make a simple mistake, you can get most of your credit. There is a common error that students make in this part that is minus 2. But if everything else is right, you get your 2 points. So Ali, let's see, each decoration he made has a radius of 2.5 inches. It's a sphere. And the weight of clay is 68 pounds per cubic foot. Determine and state to the nearest pound the total weight of 6 decorations. Again, we should probably convert to feet. So if 1 inch, if 12 inches is equal to 1 foot, then that 2.5 inches is equal to 2.5 over 12 feet. Okay, so I'm gonna use that as the radius. So the volume of one decoration, capital D for decoration. So let V sub D equal the volume of one decoration. So V sub D is equal to 4/3 pi r cubed according to the formula sheet in the back of the test. I didn't memorize that. I did memorize that at this point, but You don't have to memorize it. If you're like, I don't remember the constant, go to the formula sheet. And it's not cheating, it's given to you. Okay? Just go there. So it's equal to 4/3 pi 2.5 over 12 cubed. And I actually get this answer to as many decimal places as the calculator gives me, and only round at the end. Okay? 4/3 times pi times 2.5 over 12. Notice my parentheses, cubed. 0.03. And then I'm going to multiply this by 6. V total is equal to 60 is equal to, I'm doing that now before writing down the number so I can just drag the image, and 6 times this answer. That. Okay. I'm going to drag this over here. Okay. Oops. Okay, that didn't work out. Let's try it again. Okay. There we go. And we get 0.03787606668. And for the volume total, that's not 6D, it's 6VD, V such D, 0.227256413. Common question. Doesn't it take a really long time to write all these numbers? And is it worth it? No, it actually doesn't take a long time to write all these numbers. A lot of times that teachers debate whether it's worth our time to write all these numbers, and students debate it, and then they round and round, and then there's so much rounding along the way, and the rounding adds an error. It's not worth it. The reason I train students to write all the numbers and then round at the end is that it fixes a lot of problems that students make. And since I'm not live with you, I can't fix all your problems, but this one fixes problems very quickly. So now I got the volume, and now I have also the density. Let me see the total weight. I know the density. So density now is equal to mass over volume. By the way, this is 2 points already. Density, I'm trying to get my final points. Mass over volume. Plug in some numbers. 68 is equal to the mass over 0.227256413. Put it over 1 so I could do my nice cross multiplication. And I get that m times 1 is equal to 68 times 0.227256. So now I'm running out of space. So now I need to just write a little smaller. Equals 6.8 times 0.227256413. And then m is approximately equal to, I get that. I'm going to write that answer as is. Again, because it's a problem fixer. Times 68. 15.434 609. 3609. 4543, sorry. 454343. 4609. And so the mass is approximately equal to, now this is where I go to the nearest pound. The 4 causes us to keep this the same. So 15. And they gave it nearest pound, so we keep it there. And we got 4 points. And lots of different places where we can get points. Just getting the volume of one of them is a point. Getting the volume of all 6, that's another point. That's 2 points. Putting in density equals mass over volume and making an arithmetic error there, you could get 3 points there. But if you do it correctly, that's 4 points. And finally, we're at one of the most insane proofs that ever come on a Regents, excuse me, and why am I telling you, like a lot of teachers tell you, don't even bother with the proof. Worst advice that I could give, that a teacher could give, because when I tell you proofs have so much partial credit involved that it's just like sprinkled on there, you'd be surprised what you could do. Because here's the thing, here's the thing I want you to remember about a proof. If you could prove anything about the shape, it's almost guaranteed to be in the correct direction of the final answer. So my advice to you is to give answers, give work that is correct. And look at this grading. I need to show you this grading. Look at this. Okay, 0 response, does not contain enough relevant information. Good. If you just write the given, it used to be that sometimes they would give you a point for just the givens, but now they don't. But here, only one correct relevant statement beyond the given is beyond the statement and beyond the givens is provided, is given. So if you just write one additional relevant statement, that's a point. Look at this. If 4 or more statements are missing or incorrect, which is technically like saying that you have 2 correct statements, kind of like that. It's not quite like that, but yes. And it also depends on how many steps the prover, the grader, took to prove it. Here, 3 points. If 3 statements are missing or incorrect. 4 points if 2 statements are missing or incorrect. And 5 points if 1 statement is missing or incorrect. Tons of multiple choice. I'm sorry, not multiple choice. Tons of partial credit. That's the word I was looking for. Tons of partial credit. So that's what I'm gonna teach you how to get right now. I'm gonna do the proof completely, but I'm gonna teach you how to get the partial credit. The first thing I'm gonna do, I'm gonna write statement, and I'm gonna write reason. Actually, I'm going to move this over a little bit because I'm probably going to write it in 2 columns, 2 sets of 2 columns. Statement, reason, and I'm going to do number 1, and number 1 is going to be given. Here is the hint. I'm going to first write down all the given information, but I'm not even mentally going to process it. That's my advice to you. So follow my advice here. I'm going to write the given information. I'm not even going to process it. Ready? So in quadrilateral hope below, so quadrilateral hope below, I don't have to say below, quadrilateral hope, it says EH congruent to OP. I'm not even processing it, I'm just copying and pasting. EP congruent to OH, IO. EJ congruent to OG, and TG and YJ are perpendicular to diagonal EO at G and J, respectively. That was too much information for me to process. So I just did that without processing it. I promise you I did that without processing it. What's my advice? What's my advice? To scrounge up as many partial credit points here as we physically are capable of scrounging up. If I didn't even process the givens, what's my advice? And by the way, if you appreciate all the advice that I've been giving you, I do appreciate it if you hit the subscribe button. That's how I get paid for this. And if you do want to visit JuanTutors.com, you feel like I might be able to do something good for you, please do visit. I also have a lot of other math tutors and English tutors working for me. But if all I get from you is the subscribe button, that's actually super satisfactory to me. I have some additional resources in the description, so please do also visit those. Here is how I'm going to scrounge up points. I didn't process the given information before, but I am going to process it now. Okay? So how am I going to process it? I'm also going to label it here. So it says that EH is congruent to OP. EH is congruent to OP. That's the very first given piece of information. In quadrilateral hope, which is a quadrilateral, HOP. Okay, EH congruent to OP. Unfortunately, there's nothing that I could prove with just that one piece of information. So I go to the second piece of information. EP is congruent to EJ. EP is congruent to OH. That's huge. Now I'm processing. Now what I've noticed is I have a quadrilateral with two pairs of congruent sides. That's a parallelogram. So HOPE is a parallelogram because a quadrilateral with two pairs of opposite congruent sides is a parallelogram. It's a parallelogram. And I just got a point. Do you see that? I'm processing the givens one step at a time, and I'm eking as much information out of it as I can. Now, I do want to say, what's my goal? I want to eventually see that TG is congruent to YJ. It does help to know what direction I'm going. This little tiny line segment is congruent to this little tiny line segment. I see that it's part of a triangle. But right now, I might be so lost, I'm not even sure. So now that I know, though, that these are that this is a parallelogram, I know that the top is parallel to the bottom. And that's probably very useful. So now OH is parallel to EP because opposite sides of a parallelogram are parallel. So now I'm, depending on the grader, that might actually be a second point. Because remember, if I'm 4 steps away from a final proof, then I get 2 points. So I'm getting points here. Now, by having parallel lines, the moment I have parallel lines, I'm instantly thinking about transversals and alternate interior angles, alternate exterior angles being congruent. And that's actually what happens here. That's my next step. So I haven't even gone to additional steps. So let's see. So statement and reason. So my next one, I'm going to actually say that this angle, because now I'm looking for congruent triangles maybe. So now angle YOJ, angle YOJ, I want to do this in red. Angle YOJ is congruent to angle TEG that I labeled in red, but I'm actually going to, in blue, but I'm going to actually change those to red. Because now I'm starting to get closer to actually a some triangles being congruent, which is super. Okay, and the reason is step 4, alternate interior angles are congruent. If you say anything at all, it's probably in the right direction, and that actually just remains true. And if you just keep saying things that are true, you might find that you can get really far with the proof. But if you actually go into the next given, EJ is congruent to OG. You already said this, so you don't have to give this. EJ is congruent to OG. If you subtract GJ from each, then you get 2 congruent line segments. So I'm going to say that well, first off, GJ is congruent to itself. GJ is congruent to GJ, JG, GJ or JG, by the reflexive property. And now, since EJ and GO are congruent to each other, I'm going to now subtract this piece from both of those, GJ from both of those, and get two congruent segments. So I'm going to get 1, 2, 3, EG congruent to JO. So is that EG is congruent to JO, OJ, OJ. By the subtraction postulate. And so now I have these two little triangles that are starting to look very congruent to each other because they have one pair of angles congruent, YOJ and TEG, and they have one pair of sides congruent, EG and JO. If I can get either one more side or an angle congruent, then I can actually get them that they're congruent. And in fact, if I look at the fact that TG and YJ are perpendicular to these diagonals, there's actually my third set of angles. I could say in one step that these two angles are right angles, and I could say in one step that they're congruent. So angle TGE and angle. No, but I'm going to say it in a different way that I know more recently in these regions that they've been allowing. Immediately, you could say that they're congruent right angles. So perpendicular, so that angle TGE is congruent to angle YJO because perpendicular lines form congruent right angles. Okay, so that's in one step, I said it. And now the two little triangles are congruent. Because by side angle side, triangle EGT is congruent to triangle OJY, 8. And that's by angle side angle postulate. So how's angle side angle? Angle TEG and YOJ. So that's one angle. The included side is EG and JO. The included side pair. And then the final angle is angle TGE and angle YJO. And now we're actually one step away from the final proof. And again, I want to say, if you followed along this whole time, I really appreciate that you've gotten this far. Not because because you're watching my video and I get credit for the hours. That's fine because it's not like I get paid a ton of money for your view. I just want to give you credit for the amount of effort that you've been putting on doing the best that you can for this test. So if you have only a few more hours left or a few more days left, my advice to you is to actually retake this test again. And then for every single question that you didn't know how to do it perfectly correctly, write down everything that I did and then retake the same test again. And you should be able to retake the same test and finish it in like an hour and then go to a new test, okay? So we're gonna finish this. We're gonna drop the mic and then we're gonna exit and that's it. So the last step and the proof that the TG is congruent to JY, which is what they wanted, TG is congruent to JY, YJ is corresponding parts of congruent triangles are congruent. And at this point, we pick up the mic, we drop the mic, and we say bye. Congratulations, good luck. I know you could do it. All right.